digo porque hay algunos que no sé.
Hola, traducción. Hablarme, por favor. Prueba. Canal 1, en el 2. ¿Sí? Sí. Hola, sí, 1, 2, 3. Perfectamente, sí. Perfecto, alto y claro, sí, muy bien. Cre- Creo que sí, en cualquier caso la microfonía es la misma para toda la sala. Sí. No, 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 no. Ok, ahora.
Mr. Hernández Carón, Dr. Sánchez Margallo, Ms. López Martínez, distinguished participants, ladies and gentlemen, good morning. It gives me a great pleasure to welcome all of you and present the authorities this morning to the European Workshop of Advanced Technologies for Training in Minimal Invasive Surgery, jointly organized by Jesus Usón Minimal Invasive Surgery Center. First, I have the floor to speak the University Extension Vice-Rector of the Extremadura University, Ms. Isabel López Martínez.
Señor consejero, señores directores del CCMI, profesores, expertos, distinguido público. La UE se congratula de estar presente en la inauguración de esta jornada científica de ámbito europeo y tiene varias razones para ello. En principio, la vinculación que se ha establecido entre la UE y la Universidad de Extremadura y el Centro de Cirugía de Mínima Invasión, que es cada vez más estrecha. Recientemente, el Consejo de Gobierno de nuestra universidad lo admitió como centro adscrito y, desde luego, la colaboración en las labores de enseñanza y de investigación pues ya ha sido muy fructífera y muy rica antes, pero en el futuro, en el presente y en el futuro, pues esperamos con todos nuestros deseos y toda nuestra fuerza que sea muchísimo más. Además, la UES creo que debe funcionar como una cantera de investigadores. Tenemos facultades muy ligadas a la investigación también que puede desarrollarse en ese centro. También otra de las razones de alegría y de satisfacción para la Universidad de Extremadura de estar aquí es que, de nuevo, vemos que el Centro de Cirugía de Mínima Invasión muestra la firme apuesta por la investigación puntera en diversas disciplinas del campo médico-quirúrgico. El Centro de Cirugía de Mínima Invasión sigue una línea capital también que es muy afín a la continuada por la Universidad de Extremadura, y es la internacionalización. En esta jornada pues vemos que se van a reunir diferentes expertos de también países diferentes, españoles, alemanes, portugueses, polacos, para debatir y para mostrar sus conocimientos mutuamente unos a otros. Uno de los principales ensayistas de la actualidad, George Steiner, en un libro magnífico, habla de dice George Steiner, la libido sciendi, el deseo de conocimiento, el ansia de comprender, está grabada en los mejores hombres y mujeres. Yo creo que en esta jornada se presentan proyectos, logros ligados, claro está, al ansia de conocer. Y por eso yo creo que el Centro de Cirugía de Mínima Invasión se caracteriza precisamente por estar en la puntera del conocimiento y por esa labor también de conexión, de enseñanza y de verter el conocimiento que aquí se gesta hacia el exterior para poder ser útil. Para acabar, esto es muy breve, solo es la expresión del deseo, de la satisfacción que la universidad tiene de estar acompañando el CCMI. Yo quería recordar también unas palabras del principio del Eclesiastés, el libro bíblico, que dice: quien da ciencia, da dolor. En la Biblia, el sentido de esta frase, de este versículo, está relacionado con el mito de Prometeo, es decir, con la insatisfacción muchas veces del investigador, con la angustia del deseo de saber siempre más. Yo interpreto, sin embargo, esa frase del Eclesiastés en este contexto de una manera diferente. El conocimiento que se va a generar aquí, lo interpreto por refutatio, el conocimiento que se va a generar aquí no es para causar dolor, sino al fin y al cabo para aliviar el dolor de mucha gente. Como digo, enhorabuena a los organizadores de estas jornadas, que espero que sean muy, muy provechosas. Muchas gracias.
Thank you for your words. Now, it's my pleasure to introduce you the Scientific Director of Jesús Usón Minimal Invasive Surgery Center, Dr. Francisco Miguel Sánchez Margallo.
Muchas gracias. Consejero de Salud y Política Social del Gobierno de Extremadura, vicerrectora de Extensión Universitaria de la Universidad de Extremadura, señoras y señores, colegas y amigos todos, buenos días. Para mí es un placer darles la bienvenida a este European Workshop on Advanced Technologies for Training in Minimal Invasive Surgery que vamos a desarrollar durante esta mañana. Dar también la bienvenida a todos al Centro de Cirugía de Mínima Invasión, Jesús Usón, y, como no, darle la bienvenida a los colegas que vienen de otros países y fuera de la región, a Extremadura y a Cáceres. En primer lugar, quiero agradecer el llamamiento a este workshop europeo, que ha nacido fundamentalmente de diferentes colaboraciones científicas en proyectos, tanto proyectos nacionales como proyectos europeos, también las colaboraciones con sociedades científicas, diferentes colaboraciones con clínicos, con cirujanos dentro del mundo de la medicina y, como no, diferentes colaboraciones del Centro de Cirugía con el mundo de la ingeniería. En el caso del Centro de Cirugía cumplimos 20 años de trayectoria en cuanto a la formación médica. Ya van a ser más de 13.000 alumnos de diferentes especialidades médicas los que se han formado aquí en el Centro de Cirugía, recibiendo anualmente unos 1.600 alumnos para realizar formación quirúrgica que finalmente trasladan o aplican a sus pacientes. Comentar también que en las actividades del centro organizamos anualmente más de 125 actividades de formación, por ejemplo en el año 2013, y que más del 60% de ellas están relacionadas con la cirugía laparoscópica, de ahí la importancia, la trascendencia de la formación en cirugía de mínima invasión en el ámbito sanitario. En cuanto al centro, nuestro objetivo fundamental pues, es ofrecer una oferta formativa de alta calidad, sobre todo que redunde en una mayor calidad asistencial en los pacientes, sobre todo en los pacientes humanos que son intervenidos en los hospitales. Evidentemente, trabajamos también para crecer en las actividades de formación en el centro y, como no, pues queremos ser un referente nacional e internacional en cuanto a la formación quirúrgica y al uso de nuevas tecnologías en cirugía y sanidad en general. En cuanto al workshop que vamos a organizar, como ya comentaba, es una mañana de trabajo donde intentamos poner en orden diferentes temas con los cuales nos vamos encontrando en el desarrollo de los proyectos y en el trabajo diario, como es el uso de la tecnología en la formación médica, sobre todo determinar exactamente el alcance que puede tener, las necesidades o vías nuevas para, por ejemplo, certificar o acreditar las competencias quirúrgicas, que es un tema que está aún por resolver, sobre todo en Europa. También conocer las necesidades de los clínicos, las necesidades formativas del sector médico y, como no, pues conocer las experiencias de otros socios que estén trabajando en temas de formación, así como en investigación en el área tecnológica. En este workshop hemos citado diferentes socios con los cuales trabajamos en proyectos nacionales y europeos, a clínicos, a ingenieros y, bueno, también estar en contacto a través de Internet diferentes socios de países europeos. Y, como comentaba, bueno, pues queremos poner luz en estos temas y, sobre todo, guiar los pasos futuros en el campo de la formación en cirugía de mínima invasión. Quiero agradecerles a todos la asistencia. Recibimos hoy colegas de España, de Alemania, de Polonia o Portugal, físicamente, también a través de Internet, colegas de Hungría, de Rumanía, de Grecia, con los que estamos trabajando en el ámbito de la formación quirúrgica, de la formación en cirugía de mínima invasión. Durante la jornada vamos a tratar temas interesantes sobre la formación online, la formación quirúrgica, la evaluación de competencias quirúrgicas, el empleo de nuevas tecnologías para la evaluación ergonómica, la validación de diferentes conceptos de entrenamiento, la visión clínica en cuanto a la formación quirúrgica, la innovación tecnológica, el alcance de la innovación tecnológica en la sanidad, el uso de tecnologías como puede ser la tecnología de vídeo para la formación y también el uso de la simulación para la formación médica. Espero que sea una jornada de provecho para todos y nada más. Muchas gracias.
And finally, I'm pleased to present you the Minister of Social Health and Care Politics of Extremadura Regional Government, Mr. Luis Alfonso Hernández Carrón.
Muy buenos días. Director científico del Centro de Cirugía Mínima Invasión Jesús Ursón, profesor Sánchez Margallo, vicerrectora de Extensión Universitaria de la Universidad de Extremadura, doña Isabel López Martínez, profesores, expertos, asistentes que nos acompañan, investigadores que también nos acompañan por videoconferencia. Muy buenos días a todos y muchas gracias por su atención. En primer lugar, agradecer la invitación a participar en la apertura de este encuentro de ámbito científico que reúne en nuestra comunidad autónoma, en la ciudad de Cáceres, a profesionales que de alguna u otra forma participan en el desarrollo de tecnologías avanzadas para la formación en el campo de la cirugía mínimamente invasiva. También quiero darles la bienvenida a los que acuden por primera vez a nuestra región, a Extremadura, a esta ciudad, a Cáceres. Espero que su estancia aquí sea provechosa y además les permita conocer los encantos de nuestra tierra. Una vez más, gracias a este encuentro, Extremadura reúne expertos para abordar aspectos sobre la cirugía mínimamente invasiva. Hablamos de un campo que, si bien se enmarca en la historia reciente de la cirugía, ha alcanzado en nuestros días unos niveles de desarrollo dignos de mención y que en el caso de nuestra comunidad autónoma, este desarrollo no puede explicarse sin el trabajo de los profesionales que realizan en este Centro Jesús Ursón. Todos ustedes son conscientes de que muchas de las ventajas ligadas a esta práctica quirúrgica y sus beneficios alcanzan a pacientes, a profesionales y al propio sistema sanitario. En el caso de los pacientes, se pueden citar ventajas como la reducción del dolor posoperatorio gracias a la ausencia de incisiones quirúrgicas importantes. Los profesionales además se encuentran con menores complicaciones en la herida quirúrgica y una mejor respuesta inmunológica del paciente. Y si tenemos en cuenta que según algunos indicadores, el 50% de los internamientos hospitalarios están ligados a posibles complicaciones y al periodo de convalecencia posoperatorio, es fácil adivinar una serie de ventajas para el sistema público sanitario, entendida sobre todo como una disminución de los costes asociados al ingreso hospitalario y una disminución de las listas de espera. Por lo tanto, apostar por la cirugía mínimamente invasiva es apostar por el sostenimiento de nuestra sanidad pública. En Extremadura, de las 4.771 prestaciones que aparecen en nuestra cartera de servicios de intervenciones quirúrgicas, nuestro servicio de salud encuadra 255 en el concepto de cirugía mínimamente invasiva, lo que da buena muestra de la necesidad de continuar impulsando esta nueva técnica quirúrgica. Por todo ello, desde el Gobierno de Extremadura, entendemos que cualquier planificación sanitaria sería errónea si no incorporase entre sus premisas fundamentales la apuesta decidida por esta técnica, por la cirugía mínimamente invasiva. Así lo entendemos y así lo expuso también el presidente de Extremadura hace unos meses, el señor Monago, cuando anunció que en la finalización del nuevo hospital de Cáceres jugaría un papel fundamental la potenciación de estas técnicas quirúrgicas. De este modo, el nuevo hospital de Cáceres se convertirá en un centro hospitalario de referencia en materia de innovación. No solo atenderá ese hospital las necesidades sanitarias que requiere esta ciudad y los ciudadanos también de su provincia, sino que nuestros esfuerzos se centran en convertir este nuevo centro hospitalario en una referencia internacional en materia sanitaria y en técnicas de cirugía mínimamente invasiva, y por ello tendrá a disposición la tecnología sanitaria más avanzada. Tal y como anunció el presidente Monago, el nuevo hospital de Cáceres dispondrá además de un espacio asistencial donde el Centro de Cirugía Mínima Invasión Jesús Ursón no solo realizará por primera vez en Extremadura ensayos en fase clínica con pacientes, sino que también pondrá en práctica el tratamiento de algunas técnicas quirúrgicas que son pioneras en Europa. Pretendemos que este centro de cirugía mínima invasión en el que nos encontramos tenga el apoyo y la continuación de las investigaciones en un hospital público que se encuentra justo al lado. El presente y el futuro de nuestra sanidad debe encontrar en la cirugía mínimamente invasiva un elemento impulsor, un aliado en beneficio de nuestros pacientes, y eso exige que profesionales se formen en estas técnicas quirúrgicas. Es necesario extender entre los sanitarios el conocimiento y las habilidades de estas prácticas. De ahí la importancia de encuentros como este, que impulsan la innovación, el conocimiento práctico, mediante la colaboración y desde una perspectiva europea. Por tanto, para finalizar, quiero animarles a que participen activamente en este encuentro y desearles el mayor de los éxitos. Muchísimas gracias.
Okay, thank you for the authorities. We are going to start for the first part of the workshop. Please, all the speakers for the first part come to the table. I would like to inform you that in the channel 1 you can listen the English version of the workshop, and in the channel 2 you have the Spanish version. If you need any headphone, it's available on the reception side. Okay, the first presentations, it's performed by Víctor Primo, project leader at IBB, Instituto Biomecánico de Valencia. Please.
Well, thank you, Blas, for your introduction. Well, first of all, good morning to everyone. I want to thank you to the CCMI, the organization of this workshop. Thank you, Blas, Juan, Francisco. Well, I'm going to start. Today I'm going to present, I'm going to make a brief summary of a lab form project that is a lifelong learning program project, and it's titled Online Vocational Training Course on Laparoscopy Ergonomics for Surgeons and Laparoscopic Instrument Designers. As you could see in the index, I'm going to make a little introduction to the project, but I will focus my presentation on the methodology that the consortium has followed during all the project to achieve, to fulfill all the objectives that we agree at the beginning of the project. So I'm going to talk about the formative needs detection that we perform. I'm going to talk about the VET curriculum, the vocational educational training curriculum, and the training contents. And I'm going to finish with a brief summary of the pilot test results that we have obtained recently. So, where did the idea of the draft for project come from? Well, as you should know, the field of surgery is currently undergoing drastic changes in an effort to provide less invasive solutions for patients. Laparoscopic techniques represent a key milestone in the development of modern surgery, and it has been adopted as the gold standard for a growing number of procedures, improving quality of care, patient satisfaction, and efficiency in the use of health service resources. Novel techniques such as laparoscopic single-site surgery or natural orifice transluminal endoscopic surgery are gaining clinical importance, and applications are growing rapidly. These techniques may provide several advantages over open surgery procedures, like faster recovery, shorter hospitalization, lower post-operative pain, and better cosmetic results. All these things contribute to increase the number of services and professionals worldwide who use minimally invasive surgical techniques. However, laparoscopic surgery is more demanding and it involves a series of risks for the surgeon. In fact, the increased technological complexity and poorly adapted equipment and surgical instruments can lead to an increase of complaints of surgeons, fatigue, and physical discomfort during laparoscopic surgery. As you should know, surgeons can suffer shoulder pain due to the malpositioning of their arms. They can have cervical pain, etc. So these situations or these complaints can be addressed by the introduction of ergonomics to their training. In order to fulfill or to address the lack of training programs on ergonomics and ergonomic guidelines for surgeons combined with the poorly designed surgical tools, not considering ergonomics in the design of instruments. Taking all these things in consideration, LAFOR project aims to create, implement, and set the basis for a pan-European exploitation of a new online vet course in laparoscopy ergonomics applied to product design, instruments, and equipment, addressed to design professionals and posture and workplace-related ergonomics for surgeons. To this end, we count with the participation of the following institutions: Centro de Cirugía de Mínima Invasión, Jesús Usón, here in Spain, in Cáceres. We count on with COMAC, the Institute of Mining Technology from Poland, the Silesian University of Technology from Poland too, with la Sociedad Española de Cirugía Laparoscópica y Robótica, SECLA, from Spain, the Institute of Biomechanics Trauma Center Murnau and Paracelsus Private Medical University of Salzburg, and the Instituto de Biomecánica. As I told before, I'm going to talk you about the methodology that the consortium follow in order to comply with this objective. So here in this picture, you can see the four main steps to fulfill with to carry out with the project. The first task, the main task was the formative needs detection for surgeons and designers. Okay, this task will let us to know which were the main complaints or problems that surgeons have during surgical procedures, and to address these problems from an economic point of view. Once we had the formative needs, we can start the development of the VET curriculum, the Vocational Educational Training VET curriculum. That is a document that gathers all the information about the structure, about training contents of the courses, and is the base in order to develop the training materials. Once the training materials are developed, we can follow in order to evaluate the quality of these training materials by the use through carrying out a pilot course with real students and users. With the results obtained of this pilot course, we can make modifications of training materials and translate to other languages. For the formative needs detection, we select a methodology based in two phases. The first one, the qualitative phase, give us information, general information about the complaints or the ailments of the surgeons during the surgical procedures. In our case, we selected a focus group. We carry out a focus group composed by 11 laparoscopic surgeons. They were asked about their problems during surgical procedures. They told us about their training on laparoscopy, etc. From these results, from the obtained results, we carry out the phase 2, a quantitative phase, in which we have prepared a special survey for surgeons in order to gather a more specific information. Okay. For the course of designers, we passed really to phase 2 because it was very difficult to gather people dedicated to the design of laparoscopic instruments. So we decided to prepare a specific survey and to send them by mail or by email. But we had a problem at this detection phase, and we had no response. Well, designers is a target group that is very protected by the companies, and reach them is quite difficult. So what we do with in this case? Well, we use the formative needs detection results of surgeons in order to elaborate a list of formative needs for designers, because we detected that all the problems that surgeons had in their surgical procedures are based on two sources. The main source is the lack of formative training in ergonomics, but the second is that instruments and equipment don't follow during the process of design, don't follow any ergonomic criteria. So we think that in order to address all the problems of surgeons, we have to prepare a double course. We have to divide the planned course in two specific courses. One addressed to surgeons, and the other one addresses to designers, but with the same methodology. Well, I talk about the formative needs detection, and the following step is the VET curriculum and the development of training materials. The main objective of VET curriculum is to define the course structure and learning methods, to define the evaluation methods that we will follow during the course, to establish a recognition framework, and to define the learning objectives of these courses. For the development of training materials, we had to select a structure for the contents. So at this picture you can see which is the structure of the content that we have developed. All the training materials were divided in modules, and each module was divided in work sessions, and each one of these sessions had specific contents as previous ideas, the teaching unit with the objectives of the working session, topics, key ideas, and activities to consolidate the knowledge acquired. For the pilot test phase, we prepare all the contents in English for both courses, for the course addressed to sergeants and the course addressed to designers. And here you have the structure of both courses. The course for sergeants was divided in 5 modules with 10 sessions, and the course of designers was divided in 4 modules with 12 sessions. We counted on with 39 users in total, 20 laparoscopic surgeons and 19 designers. Here I show you a couple of screenshots of the e-learning platform. Here, this is the distribution of the information. Here we the left, on the right side, we have a panel with latest news, administration, people who is connected, etc. And on the left side, we can find all the content materials. Here we have, as an example, the distribution of information of one module. This is a module for the surgeon's course. We have 3 sessions with 3 didactic units, 3 introduction to this didactic unit, and each session has a questionnaire. This questionnaire was prepared in order to evaluate the platform and the e-learning contents for an improvement of these courses. The pilot test was evaluated in two parts. In the first part, we evaluate the e-learning platform through the use of 12 closed questions that ranges between 0 and 5, and 3 qualitative and 3 open questions. In the case of contents evaluation, we use 8 closed questions and 1 open question. Here I will show you a brief summary of the results obtained during the pilot test. This first picture shows us the evaluation of the e-learning platform performed by surgeons in the course of surgeons. As we can see, the lowest score was 3.5 out of 5, and the highest was 4.2. The aspects that we evaluate were, well, if the platform was easy to access, the aesthetics of the platform, if the platform was well organized. Well, in general, questions about the platform and their aesthetics, and we get very good results. Of course, the designers, we have the evaluation of the designers of the platform. We have the same aspects to evaluate, and we get very good results too. Maybe a little bit lower in average score, but we get very good results. Regarding training contents, here we have the evaluation of surgeons. The course for surgeons gets very good results with scores between 4.16 and 4 for all the aspects. Well, we can highlight that the surgeons consider that all the contents have a good technical quality. Almost the same for designers, with a little bit lower scores, but very good results too. So to conclude, as main conclusions, the course structure, topics, duration, and technical quality of the contents were rated as good or very good by most of the users. Feedback provided during the pilot test gave a positive evaluation to both courses, and the online courses developed allowed to achieve its main purpose and deliver a basic training course for professionals that wish to improve their knowledge and practice in the domain of laparoscopic surgery. So at this moment, we are translating all the contents from English to Polish and German and Spanish. And the project ends this September after 2 years of project. So we are very proud from our results. I think that they are very good results, and I hope we can continue with this work in future projects. So thank you so much for your attention, and if you have any questions. Okay. Hasta aquí.
The attendant, please feel you free to ask anything that you need. We are trying to promote the collaboration between participants, so if you have any question about the projects, about the future lines, anything that you have in mind, please feel free to ask to the speaker, even to the attendants. If you have any question, it will be a pleasure for us to promote the roundtable at the end of each speaker. So the next speaker is Dr. Francisco Miguel Sánchez Margallo, Scientific Director of Jesus on Minimal Invasive Surgery Center. Please.
Sorry, there is a problem with the computer. Okay.
So sorry for the technical problems. We are trying to solve the problems. We continue with the presentation. The following speaker should be connected to conference, so we can skip it and leave it in the original position. So Javier Sanchez, the learning coordinators Jesuso Minimal Invasive Surgery Center, will be present his work now.
Gracias, buenos días. Thank you. Good morning to everyone. First of all, I want to thank to the organization of this workshop to giving us the opportunity to show you our projects. I have started the training coordination of this institution. However, there are many people working in this area. In addition, for people indicating the screen, there is colleagues from some scientific units of the center and other external clinical experts that are providing their point of view. We expect and with this collab will be a tool for the objective evaluation of the capacities that a surgeon tends to promote a surgical technique. With this presentation, I would like to show you how. Well, in Spain, and in a similar way to in the rest of Europe, the education of urology demand in the study in a university, and then a period of residence in a hospital for 5 years. During this time, the evaluation to the surgeon is educational and continuous. That is, through theoretical and practical exam and direct vision from the tutors. This is called formal education, educación reglada in Spanish, and follows an official study plan established by the national health government. From this moment, the training of the medical professionals is going to depend on their interests, ability, and possibilities. Availability of the equipment, material, and methods in the hospitals, and possibilities of time and economic resources. This is why, after finishing the residence, the urologists don't have obligation to surrender to any more evaluation than the one is realized across the continuous education. However, within the health quality program of the different regional government, has been developing for years about quality accreditation program for units or surgical service in the hospital. We wonder then, is this system the best for the training of surgeons? When we carry out an activity, we do it according to our capacities. The result for the same activity can be quite different. And the fact that we do it doesn't mean that we do it right. All this has to do with a concept, competence, which define in English as the condition of being capable, ability. This concept we will see later. If we attend to the traditional education model for the surgeon has a very passive role. The system continues the mantra, say one, do one, teach one. And in a complementary way, they are considered to be the skills and the knowledge. This is the mentor, the expert tutor, who decides everything, who does every activity in the hospital. But these traditional methods have been already questioned, and in some and all and new articles, is were referring to what the surgeons were thinking about this training system. Also taking into account the idea experience can mean doing the wrong thing over and over again, we see that in the last year, where there have appearance, many studies would refer to certain things to be used in an ambiguous way, in our opinion. It seems that this concept is not well understood. But in fact, what is what to intervene in the training of a surgeon? For us, there are all these concepts: behavior, skills, knowledge, and personal attributes. All of them observable concepts, measurable concepts, that shape the competences of the surgeons. So, we are developing just now a new training model where the surgeon is the center of everything. And for the same one is considered at the same level its knowledge, skills, and attitudes, giving place to the surgical competence that are defined like technical knowledge, clinical experience, and skill to apply this in definition and resolution of the problem. That's I think is the most important. The definition and the resolution of the problem in the different situations, in the different surgical situations, of course. It is true that there is already some precedent for the objective evaluation of the capacity of a surgeon, both in general and in specific situations for urology. Also, it has been considered to be tools for conventional surgery, like OSAT, as you see in the screen, and specific for, for laparoscopic, like the GOALs. In the same way, there is some evaluation method for no technical skills, and which then we already will comment, like the notage. On the other hand, we have the e-blue system, for example, from the European University of Urology, from basis scale in laparoscopic urology. However, and this is the origin of scholar projects, the current system presents, in our opinion, too, a series of lacks. There is a certain degree of sensitivity in the evaluation of a subject with the traditional system of parameters evaluation by Likert scale. There is not a systematic summary of no technical scale. A follow the different evaluation is not described, neither a few basis parameters associated with sanitary quality results. There is not a database of competencies associated with the different surgical techniques, with a graduation of the proof level. As a sample, if we take into consideration a typical OSAT with several competencies in evaluation, respect of the tissues, time and motion, knowledge and handling of instrument, flow of operation, use of assistant, and knowledge and specific procedure, we see that it's considered for a surgical action an evaluation from 1 to 5 points, being 1 the lowest value. We propose, nevertheless, there is evaluate only the values 1, 3, and 5. But what happens with 2 or 4? When we are in a 2 or a 4 situation, we propose to indicate the presentation, Windows tick. We propose to indicate in a clear and definite way the 5 points. The system has to allow an expert to know perfectly in what level is a surgeon for each evaluated competence. The idea is transformed to dilute the Likert scale into a system one-to-one. So we have tried to enumerate all the competences. Also, each of them has been defined and graduated. This system is known as our is more explained in the managing system, for example, in human resources. Okay. We have tried to enumerate the competence. Also, each of them have been defined and graduated by expert panel. This way, we have established, after meeting with several experts, a relation of common competence in all the techniques and a relation of the specific competence in every surgical techniques. All of them, too, they have defined and graduated. With all this information, we are developing also the first practical dictionary of surgical competence in the world. We have begun for urology because in this file, an increased need exists, but the system is extrapolated to other surgical specialties like gynecology or general surgery, of course. After consultation with several experts in urology surgery, we conclude that this was necessary at least consider all these surgical techniques in laparoscopy, urology, and microsurgery. Thinking in some kidney renal, okay. For each of the considered blocks, laparoscopy, urology, and microsurgery, we have to find one bibliographical complete revision to compile the competence of interest from urological surgery. Here you are in the screen, the laparoscopic competence, then the urology competence, and the microsurgery competence. I don't want to start for not losing a lot of time. Okay? Besides, and I said before, we have considered the note technical skill too. A skill that they don't have to see with the surgical capacity, but are indispensable for the development of the surgery, as the communication with the surgical team, for example, leadership and manager, or decision making. In addition, we want to validate the system, of course, with an appearance and content validation, in a manner that we are going to check this new tool, so a double competitive validation comparative with a golden standard. And through a validation between evaluators, of course. We love for similar criteria to defining a minimum parameters. Once we have established the benchmark with the help of an expert surgeon, we can set the minimum values we want for a particular competence. In this case, you can set the different competence and the minimal parameters established by experts. Well, As soon as the system was started, the pupil is evaluated and it is compared the result with the reference levels. With it, we will have the information, necessary information to know what competence the surgeon must improve and in which it is well. Thus, we want to be able to stabilize economic and organization effort in the correct direction. Little to little, we can adapt the training system to the real needs that we have, based never on our objective evaluation. Up to another level in all the competencies. We will consider that the competence for a concrete workplace in a certain surgical service in a hospital. This is the most important item for us. Each workplace will have its own minimal parameters. This is the best important, okay? But be careful. This must be a living system that must be checked continuously and tested according to the results in health, mortality, morbidity, number of cases, number of patients, and number of surgery, of course. After everything, we must be honest in our criteria and to assume that we can have mistakes with it. Finally, I want to remember an idea that follow our thinking about the importance of work with surgeons in a direct way. Tell me, and I'll forget. Show me, and I may remember. Involve me, and I'll understand. Thank you very much. Thank you for your passion. You have sent me a mail in this direction. This is the official sponsor and collaborator and fundamental for us. Okay. Thank you.
Thank you, Javier. Do you have any question for the work of Scholar Projects? That's the moment to make it. No? Now we connect with Julia Hensel, who's postdoctoral associate at Trauma Center Murnau, Germany. Hi, Julia.
Hello, everyone.
How are you?
Fine, thanks.
Okay.
I'm sorry that I couldn't present the project in person, but I really try my best to present the project via web talk. So I hope you can hear me clearly now.
Mm-hmm.
Okay, perfect. Yes, the project which I want to present here is the 2Health project. It's an e-learning project course on medical devices with special attention on medical regulations. What is the 2Health project? The 2Health project represents an online e-learning course on medical devices focusing on regulatory affairs and requirements for placing medical devices on market with the European Union. The project is realized with the National Agency of Germany for Vocational Training. It's a lifelong learning program of Leonardo da Vinci, which belongs to the National Agency. Our project has been starting in October last year, and it will be finished in October next year. So we are right now in the middle of the project. And this link you can see here is a link to our project website where you can get further information about the project. The main topics of the course will be in the following: to get an overview about the EU medical device regulatory, the medical device quality system and process requirements, and medical device technical specifics. The 2Health project consists on several European institutions, which you can see on the right side. The institutions are from Poland, from Spain, from Italy, and from Germany, so are from different countries. And each of these institutions has a long-lasting experience in their working field. For example, in research and development, regulatory affairs, IT, and furthermore e-learning services. And therefore, the 2Health is being developed for companies, organizations which are involved in the design and the development, in the manufacture, and/or distribution of medical technologies or medical devices. But it's also for companies, organizations which are new in this field and who want to expand their business into the medical device sector, which are working before in another sector like mechanical engineering and something like on. And for that reason, the knowledge depth of health is very different. On the one hand, the user can get a basic body of knowledge for training purposes. That may be for users who are new in the company or which are working in a company which is new in the field of medical devices. But the user can get also in-depth information. That's for employers with a medical device background. Yes, what are the learning objectives of the course? The objectives are to get an overview of the European regulatory framework for medical devices, to get an understanding of the requirements applicable before devices may be placed on the market, learn on how to comply the current pan-European registration requirements, the requirements applicable in the medical device design, development process, and requirements applicable throughout the device lifecycle. And furthermore, to get an in-depth knowledge of key points for medical device design, including risk management, usability engineering, and clinical evaluation. Learn how to comply the medical device quality requirements. Understand and comply the medical device vigilance system and post-market requirements. And now identify the different groups of biomaterials and learn about the applications. Yeah, the course is an online environment, and for that reason the course is very intuitive and highly interactive. And for that reason there are some communication and learning tools, for example, dynamic tool teaching units. That means that the theoretical content has some schematics and graphs and something like that. Activities like quizzes, forums where the user can ask questions and exchange themselves. Internal messages and email where the user can also write some emails and the professor and ask questions. Yes, how's the method of the course? The course has some different models, and there are 6 models, which means Model A to Model S. And the user has to pass all the models, and after that he could be evaluated with a final exam. The duration of the course is 38 to 40 hours. But that's only the theoretical duration. It's without the homework for the user. Each model has multiple sessions and the last session. And the last session includes a review, which is a brief summary of the content of the model, further information where the user can expand their knowledge of the topic of the model, and a self-evaluation which the user has to pass to go to the next module. And each standard session includes a set of resources, which you can see on the right side, and that's, for example, a previous idea, which is a reflection activity prior to any new topic to enable the student to be aware of what is already known about the specific content covered in the session before. Some objectives. That means that each session has defined a set of particular objectives that the user should achieve. A teaching unit, and the teaching unit consists of a document where the user can find this extended theoretical content. And furthermore, some activities like quizzes. Yes, what are the course models? The course models are, for example, the first one is the Introduction to European Medical Device Regulatory Requirements, which means, for example, the European regulatory framework where the user has to know the basics, the definitions, the scope, and the classification. Furthermore, the medical device and development life cycle, for example, from planning analysis and requirements analysis to detailed design. The medical device risk management, usability engineering, and clinical evaluation. The medical device quality system requirements, for example, with manufacturing processes, process validation, medical device vigilance system, and post-market requirements. And the last one will be biomaterials with some, for example, metallic materials and ceramic materials, for example. Here you can see an example from Module R, which was the introduction to European medical device regulatory requirements. And after the user has passed the model, the user shall be able to identify the current EU applicable legislation, standards and guidance. We should explain the main steps to enable access to the medical device market and identify critical processes and procedures applicable in the post-market phase. Here you can see a timetable of our project. Our project has been starting in October last year and will be finished in October next year. And our project begins with a questionnaire. And with the questionnaire and the results of the questionnaire, we can make an analysis and a definition of the training course content. And with these results, we can make the course objectives, which you see before on the slide. And we can create a course guide with the structure of the course. And after we get the course objectives, we will create the content of the models and sessions and define it. And after that, we make a pilot course. And this pilot course will be validated. And after the validation, the course is translated in the national languages, for example, in Polish, German, English, and so on. Furthermore, a configuration of the multi-language e-learning platform will be created. The website was created and is always updated. And through the whole time, there will be some dissemination activities like printing, flyers, the website, and so on. And here's a picture of our group where you can find us. And yeah, thank you for your attention.
Thanks, Julia. Any questions? So I would like to ask something to Julia. Do you think, Julia, that this kind of course should be available for a long time, or the medical devices regulation it's constantly changing and should be renewed anyway from 2 or 3 years ago?
Sorry, can you please repeat your question? It was a little bit.
Yes, of course. That you are preparing a really interesting course for people that it's related to medical devices, but do you think that it's an updated course for a long time, or it's only for the next 2 or 3 years maybe? Because the regulation is really changing anyway. We are not sure how long time should be.
It should be for a longer time, so it has to be updated all the time, as you said, because the regulatory affairs are changing and the labeling changing. So it has to be updated, but the project has to be for a longer time. But we have to try it and test it for 2 years, and then we have to look.
Julia?
Yeah?
Okay, thank you very much.
Yeah, thank you very much.
Any additional question? Okay, thank you very much. Now the next speaker, Francisco Miguel Sánchez Margallo, Scientific Director of Minimal Invasive Surgery Center.
Okay. Good morning, everyone. In the next presentation, I'm going to show you the European project entitled E-Learning Serious Game for Surgical Skills Training, the Curium Training System. Basically, the aim of this project is to use a serious game in a physical simulator, in a box trainer, in order to optimize the training process in laparoscopic surgery. This presentation has been organized in the following sections: background, objectives, problems, innovation and benefits, consortium, work plan, and a section for more information. Minimally invasive surgery has become a gold standard in many procedures, thanks to the different benefits for patients, such as a shorter recovery time, a lower morbidity, as well as for health systems by reducing the overall cost. However, the minimally invasive surgery requests that the surgeons acquire a set of specific psychomotor skills that are different to those of open surgery. Therefore, it is necessary to provide medical students and surgeons with new tools to train these psychomotor skills. Regarding the training model in minimally invasive surgery, I think that sequential training in laparoscopic surgery is needed before reaching the operating room, before operate human patients. In this sense, the laparoscopic simulators play an important role, and currently there is a lack of certification training in laparoscopic surgery. There is some projects in Europe working in this field, for example, LSS by EIES or eBlues by European Association of Urology, ESCOLAB by CCMI, and there is no universally recommended simple model to evaluate the training in laparoscopic simulator. We are working in these fields, and I will show you our idea in this project. In summary, the aims of the training program should be the following ones: to provide cognitive and technical skills in minimally invasive procedures, to reduce the risk and complications related with the laparoscopic surgery. Basically, the goal of training programs are to increase the quality of patient care, and we are also very interested in developing tools that allow an objective evaluation of the surgeon and surgical skill acquired during the training process. During the training period, we are looking forward to improve the patient safety and quality during the laparoscopic surgery. In summary, training programs include clinical knowledge and training, or medical knowledge and training of surgical skills. And currently, in some cases, for the development of surgical skills, we use inanimate model, experimental models, animal models, or human cadavers, and monitoring of each student during the hands-on courses. We hope that in the future we can include our simulator with a serious game during this training program. In my opinion, the ideal training program should include hands-on training. It's important to simulate realistic conditions. The training program must include theory before practice. A close supervision is necessary for skilled surgeons. It's very important to the evaluation after training, trying to find errors and areas for improvement. And the qualitative assessment of the training program should include some aspect related with the observation of the trainee, video analysis, interviews in order to find areas for improvement, debriefing, and post-training evaluation. This picture represents the different levels of training we work on here in the Jesus Usón Minimally Invasive Surgery Center. During the basic training, the surgeon has to get familiar with different laparoscopic instruments and equipment using virtual and physical simulators. Currently, psychomotor training is initially performed on surgical simulator in both trainers before performing a procedure on experimental models. Both models, the use of physical simulators and in vivo models, are usually acquired at the same time by assisting to in-person courses in a specialized training center like the minimally invasive surgery center. Using the new technologies and e-learning for distant surgical training will provide surgeons an easy access to train at work or even at home, increasing the flexibility of training, optimizing time. At this point, we are very interested here in the center in different stages of surgical training process. At level 1 or basic training, we are interested in cognitive knowledge, surgical skills, mentored procedures. And at level 3, regarding the use of new technologies during the training process, we are interested in using new technologies in the training as internet, e-learning platform, interfaces, etc. Serious games have shown a great success in different fields, and we think that their capabilities can be also applied to surgical training. This is the hypothesis of our work. And initial studies prove the correlation between performance, commercially available gains, and laparoscopic performance in box trainer. But serious gains, specifically designed for training in minimally invasive surgery and their utility as a learning tool, have not been completely analyzed. The hypothetical advantages of serious gains include the use of immersive simulations, the use even at home, the individual training, and the utility of this system must be analyzed for training, learning, and certification, and in the future, more research projects are needed. Therefore, the KTS project aims to design, develop, and validate a serious game that will provide medical students and residents, surgical residents, with innovative technology based psychomotor minimally invasive surgery training. The KTA's serious game will be based upon previous experience, our previous experience in training and learning models for surgeons, supported by a box trainer, enhancing the surgical skill training process through the ICT. We think that this project could be very interesting within the current training curricula, and not only in Spain, all over European Union, including remote psychomotor training. The consortium is led by the Jesus Usó Minimally Invasive Surgery Center, and it includes 6 partners from 5 different countries all over Europe, putting together expertise in projects in the field of minimally invasive surgery training and in the medical field, as well as with experience in European projects. The partners are ISTT from Leipzig, Germany, Abaca Technologies from Greece, Semmelweis University from Budapest, Hungary, Universidad Politécnica de Madrid from Madrid, Spain, and Medis Foundation, Campina, Romania. We think we are in a key position for improving the traditional learning process and provide new inputs to psychomotor surgical skills training in Europe. This project started on January the 1st, so the project is still in early stage. So far, the user needs and requirements of the serious game has been analyzed. For that, 4 workshops have been organized here in Spain, Germany, Hungary, and Romania. And in these workshops, the users of the serious game, including medical students and surgical residents, were invited to participate in order to know the current needs in both cases and preferences of surgeons. The differences in training process have been analyzed in order to define the final requirements of this serious game. You can find more information about the project in the website or contacting us in directly. And I would like to finish the presentation with a promotional video of the project. This video is available on YouTube, as well as the videos presenting each of the partners.
Psychomotor skills training is a key part of any formative curricula for minimally invasive surgery. The use of box trainers in the initial stage of training is widely used, but their combination together with e-learning systems is still missing. On the other hand, serious gaming is an innovative ICT approach with great success in different fields of education. It has an enormous potential to improve medical training. The KTS project will design, develop, and validate a serious game and its supporting platforms. It will allow the acquisition of key psychomotor skills through an innovative ICT-based training system, exploiting a serious game for minimally invasive surgery with distance mentoring. This combination fills the gap of remote psychomotor training, developing and validating the first serious game specially designed for distance surgical training based on a box trainer. Join and create with us the KTS community.
Okay. Okay, thank you very much. Is there any question?
I would like to explain a little more the concept of installation concept. Primarily, the idea.
Yes. The idea is to introduce the basic tasks during the laparoscopic training process. For example, coordination, cutting, suturing, using a game included inside the physical simulator. In this first step, we are thinking in basic tasks. I think it's more it could be more complicated to define a serious game, including surgical techniques or difficult maneuvers, like difficult sutures, etc. And this simulator is focused on residents, surgical residents, and students, not surgeons. This is a first stage of the future projects. I think. Hope. More questions? No?
you very much. The next presentation through Jaroslav Torkasic, manager of the Laboratory of Virtual Prototyping Methods of Komag Institute of Mining, Poland.
Thank you very much. My name is Jaroslav Tokaczyk. I represent Komag Institute of Mining Technology from Gliwice in Poland. In the Lab4 project, we were responsible in development training materials, multimedia training materials to the e-learning e-course. Today, I would like to present our methodology. The context of my presentation is as follows. First, shortly, I will present types of motion capture methods. Then the algorithm of development of multimedia training materials and the ergonomic assessment. How we created the virtual working environment and assess the equipment of localization in the operating room. And at the end, some conclusions. Most of you probably know the motion capture method. They are widely used in the film industry, in the movie industry. There are several types of these methods. First of them are the optical methods, and they are also divided in the two sub methods, where we use markers. The markers could be put locally, for example, on the fingers, or could be put in whole body on the anthropometric points. The other methods are markerless, when we don't need any markers, but we need, for example, 3D laser system. We have also inertial methods that are used, for example, when the person moves in a contracted spaces or moves in a long distance, and it is possible to prepare it in our laboratory conditions. Other methods which are in a minority, like ultrasonic methods, we also see markers, they're quite big and heavy, and others like magnetic methods, mechanical methods, and based on radio waves. In our approaching, we have chosen the markerless method. The algorithm was as follows: 3 steps based on the video registration that were done, that were carried out by Komag, Silesian University of Technology from Poland, or other members of the Lab4 project. We prepared ergonomic assessment. So we calculated movement trajectory, angles in joints, static discomfort coefficients. It helped us to identify the worst case of body posture, and at the end, extended assessment. So we prepared also recommendation in the last step, for example, height of the operating table, proper surgeon's body posture, or arrangement of the equipment. We had 2 types of video registration. First of all, we started from the surgery operation. We focused on the movement of upper limbs of the surgeons. It wasn't possible to include the motion capture method in in situ conditions. So we had several cameras in the operating room. And for the virtual working environment, we took 100 of pictures to reverse engineering this area. So the algorithm of ergonomic assessment was as follows. So based on this in situ performed laparoscopic surgery video registration, we prepared motion capture method in the laboratory conditions based on the laser system. And at the next step, we prepared motion capture method by EP Studio. It was possible to calculate static discomfort coefficient within the 3D Studio Anthropox Ergomax. And it helped us to identify the most awkward body postures. And for those awkward body postures, we prepared extended biomechanical analysis of surgeon. More details about the EP Studio method and the two last steps. As you can see, it is not fully automated method. We need to match the actor with the anthropometric model, match his movements and smooth the movements. And of course, it includes kinematic chain of body posture. And at the end, we have an input file to the next step, to the 3D Studio Anthropox ErgoMax software, where we calculated the so-called static discomfort coefficient. Is an integrated measure of level of effort of the musculoskeletal system based on three results: the resistance to motion of joint, degree of movability of joint, and value of torque in joint. At the end, we obtained this continuous ergonomic assessment for whole sequence of movement of the person, and it was possible to identify the awkward body posture. So it was possible to calculate the position of upper limbs and trajectory, the angles of in the cervical and lumbar spine, shoulders, elbows, and wrists, and also compression and shear forces between L5 and L4 and L5 discs, back muscle forces, estimated ligament strain, and force and torque regarding to body weight, and also external applied loads. This software was developed by University of Michigan. The second type of the video registration or taking picture was reverse engineering of the operating room. We obtained surface model of the operating room. After post-processing it, we could set the surgical team and, for example, assess the influence of location of equipment on the comfort of using it. This is a raw material of the operating room based on almost over 200 pictures that we have taken in the operating room. What is very important, we can measure distances between each component. After simplified this model, it is possible to set the surgical team with anthropometric models of surgeons, and we prepared assessment of height of the operating table. We can observe changes in the static discomfort coefficient regarding height of the table, different types, different heights, and also assessment localization of, in this particular case, it was the main display to the leading surgeon when it was located symmetrically or asymmetrically. So some conclusions. So we prepared ergonomic analysis during the lab project for the different heights of the operating table. Over 20 biomechanical analyses were performed. The results was continuous ergonomic assessment and extended analysis as well. Based on these results of proposed methods, it was possible to identify influence of location of the equipment on the comfort of using it, and also this motion capture method that we used are only the example, because we observed a large technological progress in this field. It is very important, the proposed methodology based on the quantitative assessment. Thank you very much. Are there any questions? Yes?
Please, can you turn on the micro? Just for the people of the streaming. Thank you.
Hello, thank you for your presentation. I find it very interesting, but I cannot imagine, because you have explained that in the previous phase of studying for developing new devices, you study the surgeon posture during the whole surgery. And I cannot imagine which kind of devices can you develop or improve with this information.
We can assess the body posture and give recommendations how, for example, we can locate the equipment on the operating room.
Okay, it's for equipment. I thought that it was for the tools that they use for operate.
Not for the tools,
okay.
No, because we didn't have a 3D model of hands in this particular case.
Okay,
but it could be achieved in the when it is possible to obtain this model of hands. It will be possible.
Thank you.
Okay.
Another question.
Thank you very much for your presentation. I'm Kostas Yannikielis from the University of Extremadura. I would like to know concerning the posture variability. If there is a movement, the amplitude of the movement is quite enough in order to have a precision in the measurement. But I would like to know what about the variation of the posture if you are trying to calculate posture with this method.
What? Could you repeat? What?
Yes, my question is that, as I know, the order of magnitude of the variation of the posture is quite small. Mm-hmm. It's too small in order to be appreciated by this technique, measurement technique.
So yes, it is also. It is.
If you have some figures of the precision of the in the calculation of the posture.
The weak point is that we had to reconstruct it in the laboratory conditions. I think the better way is when it would be to prepare the motion capture in the surgery operation room. It would be possible then.
My question is because my feeling is that the problem with work-related motor problems, musculoskeletal problems in laparoscopic surgery is the posture, not the movement of the surgeon. So up to now we don't have enough precision in the measurements concerning the posture. Yeah. The variation of the posture in angles is more or less more than 2 degrees. That's the optoelectronic, or I don't know what else, procedure for measurement. There is no enough precision in order to characterize the posture. That's my question.
We had a precision about 1 centimeter of the body posture. 1 centimeter, it was accurate. And we use the external software to calculate the static discomfort coefficient.
More questions?
Yes, a very nice experience and field of investigation. You can extend, because it seems that it's focused on the movements of the surgeon, of the posture and the movement of the surgeon, can be extended to the design of the operating room and the movements of the team, maybe in relation to the different placement of the devices for the development of the procedure. You can also analyze the movements of the team, the nurses and the assistants and all that, in order to improve the ergonomy of the whole operating room.
Yes, it would be possible, but we have to process the motion, the capture of each person separately, not at the same time.
Questions?
Thank you.
Thank you very much, Lars. The next presentation, Joanna Bartnicka, Assistant Professor at the Silesian University of Technology, Poland.
Thank you very much. First of all, I have to say that it is an honor for me to be here in such innovation research center. So I think that I go back to Poland with huge experiences. I prepared for today the presentation about research tools and techniques for ergonomic assessment, a case study from laparoscopic. The background of research is strictly connected with the project that was presented by Victor Primo from Institute of Biomechanical from Valencia. And thanks to participation into this project, we could open new areas of our research in the range of ergonomic assessment in a very interesting environment, which is operating room. And why it is so interesting, Victor said this. He said about many different parameters which create working condition in operating room, and in order to assess working condition, I prepare the solution of integrated ergonomic assessment. The methodology and material is showed in the slide. The main methods used in the data collection and building research material were literature analysis in range of ergonomic assessment methods, and because there are many different ergonomic assessment methods. Many of them are similar, but there are no the same methods. So different methods examine different kind of ergonomic parameters. The second point is direct observation and video registration of laparoscopic surgeries. It is important to this ergonomic assessment, integrated ergonomic assessment, because video registration is the base for this evaluation. The third point is measurement of joint angles by wireless sensors, goniometer and torsiometer, or with the use of three-dimensional static strength prediction software. Jaroslav from COMAC mentioned about this software, but we use I use it not for ergonomic assessment, but for identification of joint angles without wireless sensors. And the fourth point is ergonomic analysis with the use of REBA method and Anthropos Ergomax software. REBA method is a very simple method for body discomfort assessment based on codifying body position. Anthropos Ergomax was described by my colleagues, so I won't do this again. And the last one is integration of information about ergonomic features in one place in order to perform cross-sectional ergonomic analysis. And here I'm using captive software. As far as the first point is concerned, I extracted 44 different parameters which are used in different methods. I think that examining such number of features could be a good solution for complex ergonomic assessment. As I said, the base for ergonomic assessment is video recordings. So far, we have recorded 23 surgical operations of cholecystectomy, hernioplasty, sleeve gastrectomy, and gastric bypass. On the slide, you can see the way of measuring joint angles by wireless sensors. It is these pictures were taken just before surgery, and the next slide shows the situation during laparoscopic surgery. We had to know if sensors caused some discomfort for surgeons, and we cooperated with 2 surgeons, and they claimed that it's these sensors don't influence on comfort, work comfort. The data from sensors are collected in this special device. It is a data logger, and after and then the data are implemented into special software. I mentioned it is captive, and here we can see the outcomes from measurement. This is the second way of identification of body angles, but this identification, the values are estimated. The pictures from extracted from video material are included into software, 3D SSPP software, and the body position of surgeon is compared with body position of model. Thanks to this, we can recognize, we can identify the joint angles from window dialogue. According to measurements, data from measurements and from video recordings, we could do ergonomic assessment with use of REBA and other methods like Anthropos Ergomax, and we could indicate crisis situation during surgical procedure, like neck is twisted and side bending, shoulder is raised, upper arm is raised more than 90 degrees and abducted, wrist is bent more than 15 degrees down and twisted, grip is firm. And such information are used in the next step, I mean in the integrated ergonomic assessment. Here is one slide about using of Anthropos Ergomax, but as I said, it was described by Jaroslav, and I won't describe it again. Anyway, all of the information and data obtained during our research are collected in one place, and thanks to this, thanks to histograms, we can look for relations and dependencies between different kind of features influencing working condition. We can, for example, compare tasks of different people in the same time. We can find relations between body position and other features which are in the operating room at a certain moment of time. In conclusion, I can say that the complex analysis will help to discover new or little known relations and dependencies between ergonomic factors and hence improve working conditions while performing laparoscopic surgeries. The outcome of ergonomic assessment will be also could be also a content of training materials from the area of ergonomics. Thank you very much.
Any question?
Thank you very much. I have one more question, or two. The first is if you are using EMG together with ELG. I mean electromyographics.
No.
No. Okay. And the second one is that I don't know why, but I don't have a very good opinion concerning 3D SSP because it is not does not consider the pair movement. I mean movements or postures in more than one plane or concerning one axis. What's your opinion?
We use this software for several years. In my opinion, the software gives good assessment, good outcomes from our analysis. So I didn't hear about such opinion like yours.
No questions? No?
Thank you very much, Joanna. Finally, the last presentation before the coffee breakfast. It's from Bernhard Korf, Scientific Director of Innovative Surgical Training Technology Center in Germany. Hello, Bernhard. How are you? Good morning. Please, you can start your presentation.
Okay. Thank you very much, Lars, and thank you very much for all of you for inviting me to talk to you here from Leipzig. So hope you can hear me very well. And I think I will start with my talk. I switch now to the slides. I think this should work. So, and I want to show you a material about testing alternative training concepts for operative medicine. Do you hear me? Yeah, okay. So, our University of Applied Sciences is in the nice city of Leipzig. Okay, in the nice city of Leipzig, and we have a nice research center for life science and engineering with different labs for electrical engineering and also for synthetics work, and also a testing and training operative theater. What I want to explain to you is how we can improve the team of surgery and the work in the surgical cockpit, which is very similar to the airplane cockpit. So you know a lot of screens and a lot of technology over in the OR, and this is very similar to the airplane cockpit. So what is the in aviation is long is flight simulation. So the airplane pilots can train the flying in the flight system, but for surgeons it is not so easy. Of course, there are virtual simulators, but it is not possible to train in a real environment. So this is the reason why we work about virtual simulation, but the simulator alone is not enough. We need also a training concept. And therefore, we have a new project on a European level, together with you and also other clinical experts from Germany and Spain. And for developing the concept, we did a simple cognitive task analysis. So the cognitive task analysis was intended to understand how is training performed today, how can training be improved in the future. So we did an analysis of the domain, we did interviews, and we did observations of the surgeries, and evaluated the material to devise a new concept for instructions and a new guide for scenario-based training. So we analyzed the in-depth interviews, which was a lot of material, so it is possible to import all the...
Bernard, excuse me, Bernard.
Software, and then we have a lot of text of the interviews, and we analyze...
Can you hear me?
Can be improved. So how human trainers suggest to improve. Out of this, we developed a new train-the-trainer concept for train-the-trainer courses, which include educational competence, didactics, and pedagogics, which include technological competence. So, what can happen with technology is manipulated wrong, if it's used wrong, and the trainers had to devise their own surgical workshops, so based on the knowledge they are training in the trainer. So we have the trainers, we from Python. Okay. So I'm sorry that you cannot see the slides. So
Bernard, just a minute. I want to apologize the technical problem, but when trying to start again the presentation, so you can see properly the whole places.
Another screen. I think I give you the desktop, And now in the next step, it should work. Do you now see the slides?
We can now properly now.
Is it better now?
It is completely fine. If you can turn off your your phone now, your
Okay, I'm sorry. Now you can see the slides better. Of course, you know that surgical cockpits are very similar to the airplane cockpit, and you know how flight simulators look like, and you know that we have to work on surgical simulators. So in cooperation with UMISC, we did this cognitive task analysis I explained you, and we have done the in-depth interviews, and we have a special software where we can analyze these interviews and find out which cues and which structure the new courses should be devised. So based on this analysis, we devised this new concept of the train-the-trainer courses, which include its educational competence, pedagogics, and this technological competence about risk analysis, risk management, and how to handle devices and instruments. And these workshops were performed or led by item trainers. So we devised the material, and based on this material, the item trainers performed the courses to surgical trainers. So the white are surgical trainers, and these trainers developed their own course, their own surgical workshop, and trained novice surgeons. And the item trainers supervised this course by the surgical trainers, which was given to the novice surgeons. So educational competence includes feedback and assessment, and technological competence, technology risk management. So the tasks, so that we trained or we introduced the surgical trainers how to analyze tasks, for example, how to use the surgical microscope or to use other medical equipment, and how this is used by the users and in the real OR environment. So it's a scenario-based concept, a procedural analysis, risk analysis, and this concept was introduced to the surgical trainers, and the surgical trainers use this concept in their surgical workshops. So altogether, we performed courses in the area of sinus surgery in Germany, in Leipzig, in the ERDC, and currently there are courses in Madrid and also in other places of Germany. And here you see again, we use simulators. So we use simulators because it is easier on the simulator to perform this scenario-based training. So you can use real instruments, you can use real scenarios, so simulators have really the advantage that we can perform the real scenario from the OR and train the surgeons in education, in soft skills, and also in technological competence. And the same for spine surgery. We have developed a new spine surgery simulator here in our labs, and we use this simulator for training of spine surgeons. So altogether, we did also scientific analysis, quantitative, and currently this material it will be assessed, and we hope that in the near future we have all the material. But also at the current state, we can say that we have an improvement of the educational and technological competence, and that the advanced surgeons who want to become trainers ask for such courses, that they become a systematic training on this area of competence. So, of course, we work together with a lot of partners, and I'm very happy if I can answer your questions.
Thank you very much, Bernard. Any question for this project? So, thank you for your connection, Bernard. I hope to see you in next week. We stay there.
Yeah. So thank you very much, and sorry for the technical problems, but I hope you can get the message.
It's okay. We have now the coffee break. We are a little bit late, but I think that's no problem because we can recover this. So we try to take a coffee break to 20 minutes, so on, and start in a while.
Okay, we will continue with the program. For me, it's a great pleasure to introduce you next speaker, Professor Eduardo Targarona. He is Professor of Surgery at the Autonomous University of Barcelona. He is the Director of the Unit of Gastrointestinal and Hematological Surgery in Hospital Sant Pau, Barcelona. He is the President of the next Congress of Spanish Association of Surgery and President-elect of the European Association of Endoscopic Surgeons. Thank you for coming, Professor Targarona. Your turn.
For the center, and especially Professor Usson, because I think that is a wonderful project that is really a key in minimal invasive surgery in this country, and also to you personally for your friendship and also for your kind invitation to talk in this workshop that I appreciate. That really is really very important. Because the most important probably is the number of different projects that can occur surrounding minimal invasive surgery. Probably I will give to you another view of the coin, where my topic is more from the clinical point of view. I like also always to show some clips about our clinical practice. You can see here, this is a nephrectomy, it's a maximal invasive surgery with a 3 minutes nephrectomy. And here is a colectomy, and you can see how we need special features, special devices to perform this kind of surgery. And here, the lower, probably the most recent advance in rectal surgery is the transanal resection of the rectum. I want to say that all of them, the three clips have the same nucleus, the same core. Surgeons make always the same maneuvers, that is to cut, to excise, to make the anastomosis. However, the difference is technology. And probably the technology, due to the advances in minimal invasive surgery, make a very profound change in our practice in surgery. At this moment, I want to say that minimal invasive surgery is the first election for a big number of procedures. In general surgery, in thoracic surgery, in gynecology, urology. However, the most important thing is that it's much more difficult. It's much more difficult because it's performed through a screen, through a two-dimensional screen, and then something that they were not so intense in the open area in general surgery is that now it appears something that we know as a learning curve. And this learning curve is really very long. It's considered that learning curve, it took about 40 patients, for example, for colorectal surgery, or 100 for bariatric procedures. This is a big number of patients. This is a very interesting paper published very, very recently, and you can see this concept of learning curve, in which you can see that from the starting point, from the first procedure till a plateau, is a moment that you have a similar operative time and a similar complication rate. There is a time, and this time is the experience of surgeon. That means that the surgeon needs to be trained in this kind of new surgery. And you can see here, this is several different procedures, and I don't know if you can see well the figures, but you can see that for every procedure, that may be a splenectomy, nephrectomy, herniorrhaphic cholecystectomy, there is a number of procedures. At this moment, one of the most challenging procedures, like it is the colon surgery, colorectal excision, is absolutely demonstrated that is better than the open counterpart. However, in this country, probably only 35% of the patients that need a colorectal procedure are operated by laparoscopy. And that occurs not only for colorectal procedures. You can see here that also occurred. This is maybe it's a data that is 5 years ago. Probably they are sloping, they are going down very, very slowly, but you can see here that advanced procedures as nephrectomy, adrenalectomy, etc., they didn't reach more than 20% or 25% in United States. That means that there is a big task for training, and that probably is the rationale for this kind of procedures or for this kind of ideas and innovations. I will give to you probably my personal view about as a clinician and also as a teacher. I'm not an expert on the technology that has been discussed during this morning, but at least from the clinical point of view, how we have tried to solve the problem of how we are trying to solve the problem of teaching, and probably I think that is a good bet in order to look for the ideas that we need from you in order to reduce this learning curve. I think that the main problem, the main topic is how to make a surgeon really quick, convenient, proficient, quickly that compared with open surgery. Well, we talk about what is the current situation with the teaching for residents and for trained surgeons. You must understand that when you need to teach endoscopic surgery, we need to teach endoscopic surgery to a junior trainee, just as a surgeon that just finished the medical school. But also there are much less people. There were a number of well-trained surgeons in open surgery that need to move to laparoscopic surgery, and that is much more difficult. I think it's much easier to train a young people than to train an older trained surgeon. I think that you understand these differences. Also, what we have done in Spain, and also what we have done in my hospital. Well, probably something that we need to know, and I think that is quite important, is what means teaching in surgery. I want to say that also the endoscopic revolution has meant also a revolution in surgical training, because after the innovation that you can operate through the screen, also we understand that we can teach also through the screen, and that probably is also the reason of this kind of projects. Usually, it's a concept that has been not very well studied. Now I think that we have much more information. Usually, is a relationship between the master and the young trainee. Usually it was not systematized. However, at this moment, the training is much more difficult. Why is much more difficult? Because it's more complex. More complex because the reason that I said before, because you need to operate with some long instruments through a two-dimension screen. It's much costly. Really, it's much. The operating time is very, very expensive. And you cannot spend more than 2 hours, the double of time in an operating room in a hospital to train to a surgeon to make a cholecystectomy. We need to gain time, because if you gain time, you gain money. Also, this is also limiting time. Also, there is an implication on third parties. For example, the surgeon, the patient, don't want to be operated by a trainee. The patient want to be operated by the best, or at least for the people that is fully trained. And I think also that is very important. And all these factors make that this kind of training becomes much more difficult. Also, something that has been commented here, I think that is very known, that a surgeon is just not hands. Is a man that has some knowledge, must to be studied, and to know which is the disease that he is operating. And also there are some attitudes, personal aspects, personal professionalism around the surgeon. But something that it has been changed completely are the skills. The skills are composed by 3 parts. I think that is interesting to comment that. We need to prepare, to organize your brain in order to make this kind of operation. That's similar to learn to drive a car. When you go to the drive school, you don't know what happened with the motor car. You need to be very, very attentive to the brake and to the volante, etc. And the next step, when you began to understand these basic maneuvers, you arrive to drive, smoking, or you drive, talking with the colleagues, and make all these maneuvers in a way absolutely automatic. And this is the same that we need when you operate. When I operate an easy case, I'm talking about with the nurse, I'm talking with my colleagues, I'm doing something that I know to do. But the first time that I make this kind of operation, I'm looking just the structures that I'm cutting. And this is really the question, the problem that we have in endoscopic surgery, and also is the situation, the ideal situation in which technology may help to us. In endoscopic surgery, I commented before, it's much more difficult to perform and to learn. Is the really problem is this psychomotor learning, and is imaging based. And probably that is most important. If you have an image, you can play with the image. You can analyze, you can repeat, you can transfer, and that permits something that was not possible to do in the open era, as is simulation. You can make the same in a model. You can measure, you can make metrics, really you can measure the time, but also you can measure the ability, you can measure the softness of movements, you can analyze, and you can convert all these metrics in a number, in a figure. And you can say to a surgeon something that before was very difficult to say. You are operating an hernia, you are operating a gallbladder, and this gallbladder is a 5, and you need a 7. And a 7 means that you need to be more precise in the movement of the instrumentation, etc., etc., etc. And that permits also to understand better this learning curve, and also you can also maybe modify the learning curve. That probably is the most important. I think that probably the most important link between you and us is how to shorter this learning curve and how to make this learning curve safer. It probably is the main project that probably from a clinical point of view, as a surgeon, something that we need is that our surgeon comes to the operating room to operate a living patient with the most advanced way to operate. Well, something that obviously immediately after the apparition of endoscopic surgery appears all this kind of simulation. I think that probably all these references are maybe older, and we need at this moment there is another tools, and probably is one of the main interests of this session. And probably here is some just to explain a little these very important aspects of the surgical training, or the surgical development of surgical skills, with this initial step of cognition. And you can see here that you understand the task, you have the demonstration, and really the performance is a very, very erratic and not perfect. The integration is when you understand perfectly all the procedures, you can practice, and then you make the procedure much more fluid. And the ideal, that is the automation, that is the master, that really is the person that performs this procedure in a continuous fluid way. Probably we need to adapt also this evolution in the acquisition of surgical skills for a student, for a surgeon, and initiate with this kind of 3 parts of introduction knowledge, introduction technical skills, and introduction judgment before to arrive to really a very well trained surgeon. And here probably there is a big role for simulation. And also here is also the proposal for the introduction of this kind of techniques in surgical residency, but I think that is not much important. The other question is, from our point of view, that really interests people. That really is interesting for surgical educators. Well, this is a nice paper published very recently that they analyze the most influential papers in surgical education published during the last 10 years. and during the last 10 years. And you can see here, they make a search of the literature. They found about 800 papers, and of them, 23 were cited more than 45 times. You know that for a knowledge, the most important, if an idea is important, if it is cited, if other investigators consider that this idea is good. These are citations. And you can see here that of these 23 papers, 11 were related to use of simulation. That means that we are in the good way. Really, the surgical teachers are a lot of interest on this kind of procedures. The other question that is very, very important is really, and probably that is the most important, really the simulation can be transferred, really works. That means that if you make a lot of knots in a box or in a peak, when you are operating in a patient, really you reduce the operating time. That's really also very important. That's true. You can see here. I think that also this paper is quite interesting. Has been published very, very recently, because it's a systematic review. I will give some figures later. But the most important is that it includes 16 randomized controlled trials. That means that there is a group of control and then group without training and a group with training. And the trained group permits to observe that there is a reduction in the operative time, is improved when you evaluate the procedure within a structured system, and also the performance test. But you can see that these 16 randomized controlled trials, they include only 300 participants. And you can see here also, when they explain how they get this data, that when you go to the literature, there were 3,600 papers. And only of these 3,600 papers, only 16 were randomized controlled trials. That means that really hard data, scientific data that means that this idea works, is very, very low, and the quality of these trials are very low. Probably this is also a second message, and in which we must be involved. All these techniques, all these ideas should be very well confirmed that they really works in a clinical setting. At least I think that, because if you really confirm that it works, it's much more easier to implement in the clinical setting. I don't know if you understand this explanation, but I think that it's quite important. Well, let's go now to see how really it happens in the real life. I don't know how many of you are surgeons, how many of you are residents, but something that is interesting. This paper went from Canada. I think that nobody doubts about the really is a good country, and they make there was a survey that was directed to the chairmen of the department and the full professors with 34 questions, and there were 87% answers. And the idea was, which was the way that you need to learn minimally invasive surgery. And the idea were that the most preferred by the chief, by the boss, they were the go early to basic, to go early to easy cases, the laboratory and simulation in animals. You can see that is very important. Then also to go to more advanced procedures, and also it's interesting that, but was 50% of the chiefs or of the professors considered that simulation, the virtual simulation, had really a very important aspect. That means that the lab here with the animal experimentation or the electronic experimentation was very, very important. And when they considered the most, but sorry, this is just the methods that were used. You can see that only 50% of them had the ability to offer virtual simulators, but when they analyzed which were the most important aspects to try to learn to teach also, to teach this kind of surgery, you can see that was the first was the clinical practice, the everyday practice, but the second one was the lab. But there were also another survey, and then they asked to the residents, really, the boss thinks that the best is the operating room and the lab, but really, what do you have, what do you receive, which is your opinion? And you can see that these surgeons, they had, in most of the cases in Canada, access to the lab skill, to the skill lab, but they lack from a structured curriculum, and they didn't lack of advanced procedures, and also they didn't lack a very really structured academic training. But you can see here also how in both aspects, in both segments, in both views of the same problem, the lab really was very important. And some information, by example, this is a very astonishing information. We consider usually that the United States is the paradise. This is a paper that was really very striking in the United States Surgical Society, because people, the chief of the fellowship programs, that means surgeons that will try to give to you an advanced training, and it's much important to say that the most desired fellowship in the United States is minimal invasive surgery, and that also links with all this talk. When they analyze the people that they received after finishing the surgical residence, you can see that more than 30%, and in some cases more than 0.5%, were bad prepared, were not well prepared. And a surgeon, a resident surgeon in the United States, didn't lack, by example, 30%, they didn't perform a conventional, a normal, you can see here, 30% could not independently perform a lab cholecystectomy, and 60% couldn't suture, and really, there was a very important lack in technical skills. That means that, by example, and then it's for that they apply for advanced training in minimal invasive surgery. That I think that is a clear idea that we need this kind of tools, that we need to integrate these electronic tools, these devices, the new forms of training in our clinical duties. What happened in Spain? In Spain, we have a program. This is the national program in which we perform two courses. One when the resident is in the first year. The second one is when the resident is in the 5th year at this moment. And in these courses, we have a basic course that it permits to give to the resident the basic a structured training and the basic access to the endoscope, the simulator, etc. This is usually a 2 or 3 days courses that it has been very, very well accepted by the residents. And now, after to finish the first 5 years, now we are beginning the advanced course. This advanced course, that one of them will be done here in collaboration with Dr. Margallo, I think that is wonderful, because you see that the people in the 5th year of his training operating in the peak, operating in the simulator, and receiving a structured instruction, and really that permits to overlap this lack of training that we have observed, I hope, in the American residencies. Also, this is, by example, a very recent information. It's information that the number of procedures that has been performed by a surgical resident in Spain during the last 5 years is really fresh data, and we need this data. If you see here, a surgical resident in Spain will attend in a mean of 600 operations. He will perform by himself a mean of 64, that is very low, and also they will perform, they will be as a mean in 90 procedures. 90 procedures means 1 every 2 weeks. It's too low, and probably we need that this surgeon to be exposed to a minimal invasive surgery quicker and in a longer time, and probably in these situations simulation can help to us. Also, just to show how they work, this training for surgical residencies. I want to say this is also an effort of the Spanish Society of Surgery, and we give this kind of short course in to junior residents, and they have, you can see here, really an access to the basics of minimal invasive surgery. We perform these courses in every coin of the country, and with a number of people that are working on that. Also, we have a structured program with 34 teachers, accredited teachers, with some books, etc. And also, the next step, as commented before, is to give this teaching to this advanced teaching to the senior residents. To give this advanced teaching, we need especially well-structured, well-prepared centers. And by example, I think I'm very happy that Dr. Luzon and Dr. Margallo wanted to collaborate with us, because obviously this center is wonderful for this kind of procedure. I think that is something that is a very good opportunity for the Spanish Society of Surgeons, and also for the Spanish surgeons to be trained in this advanced course. And finally, just to comment, also maybe it's not so much related to the simulation, but I think that will give to you a good idea that which is the features of the problem, what we have done in our hospital. You know that due all these kind of difficulties, there is a number of different models for teaching, like the residency period, also this kind of courses for residents, workshops, experimental surgery, short stays in different centers, mini fellowships, or a formal fellowship. And also there is a different view around the world in order to give solution to this problem. One very special, very typical, very difficult to be imported to Europe is the concept of fellowship. The fellowship is a surgeon that after finishing the residence will spend 1 year only devoted to a special topic: bariatric, minimal invasive surgery, colorectal. And this is take part of the team. He's operating. He's fully integrated in the service, and this model in Spain is very, very difficult. In UK, by example, there were a much more practical point of view. They consider that, by example, colorectal surgery is cost effective and is a better advance for surgeons than the system, the health system, organize courses, and then this technique is implemented in all the hospitals. That is very expensive. That is very difficult, maybe in our country. Really, there are not any structured idea in Europe, and in Spain has been several ideas, but we propose. We have had some experience, and we just analyze some ideas before to finish. That is to make an immersion of the surgeons in the operating room, and we organize courses of 3 or 4 days, and we invite surgeons that they are with us in the operating room, and they learning how they are really looking how we perform the procedure, asking for the small tips, for the small details, and we wanted to know if really it works, because it's something that is very important when you develop any training instrument, is to the assessment, really the validation, is really to know if really it works. In this case, we wanted to know if really to develop this kind of courses was interesting for these surgeons. This was an analysis of the experience between 2005 to 2011. There were 24 courses, and I would like to comment some aspects that I think that may highlight the idea that we need, that minimal invasive surgery need additional teaching actions in order to give the development that this kind of technique merits. And in this case, we include 66 surgeons with an age of 44, and they perform in a center that they perform more than 100 colectomies per year. Most of the patients coming from university hospitals. Most of them were staff surgeons. And something that is interesting, one problem that we have as a clinics, when we introduce in a practical clinic something more difficult, is that at the end we are very, very interested. Really, I see we saw that in a congress, and I think that is wonderful, and we want to try in our hospital. We make some cases. The first case always go well, but later becomes much more difficult. And there is a lot of problems. There is the problems with the nurses, with the anesthesiologists, with the boss, because he said to you that we need to operate 2 cases, and you cannot operate 1 case in 1 morning. And then this interest declines. And we need this kind of, we observe, and you can see here, how this kind of course permitted to really to renew the interest in this area and also to consolidate the experience. Really, there was probably not too much because the people that were well trained didn't get too much information. But I think that these 2 aspects permitted the way of interest of this kind of courses that we perform in our hospital. Also, you can see here also how it permitted to increase the number of surgeries performed after this kind of courses. The surgeons come back home and they perform much more number of these kind of procedures. And also something that we wanted to know is to know if really people need additional training. And you can see how they ask positively for a short fellowships or for a short stays. Really, probably minimal invasive surgery is very, in which you don't need to be 1 year, you don't need to be 6 months. With only 3 months or 2 weeks, you can get this improvement in your knowledge that you can be translated to everyday practice. And also this is the same question, and also to say that usually the staff surgeon prefers to stay much more time than the chief of service, and the chief of service that they say that with few days is enough. I don't know if these are elaborate questions. And finally, also I think talking about the teaching possibilities that we can give to the people that have interest in minimal invasive surgery. Also in our hospital, we organize a master on minimal invasive surgery that probably is another degree. It's just to get some people that have much more interest in this kind of surgery than to be trained to develop, to investigate in this area of general surgery. Well, this is not the last, but this my conclusions. I hope that I could express which are my feelings in relation, and also that they link to the main topic of this workshop. It's clear for the professor, for the university, for the clinicians, that the way that how we teach surgery has changed completely, that this is due to the impact of minimal invasive surgery, of the new technologies, that also that we have learned a lot of things in the acquisition process of skills, that it's possible to plan, and it's for that we need probably is a special interest, all the electronic and all the ancillary tools to perform this kind of training, and probably the technology in the form of simulators or skill centers is quite helpful. And maybe we need not to give scissors and pencils, but we need to give a tablet very early to the young surgeons in order to get the best people for this wonderful specialization as it is general and digestive surgery. Thank you very much for your attention.
Is there any question? No. I have one question. As you know, in Europe, there is a lack of certification system for surgical competencies, and there is not a universal program for training. What do you know about these problems and the vision of the European association?
Yes, at the moment I think that is out of the societies, probably because that is very most important from the teaching bodies. For example, in the United States is not American, is the ACGM one, is the organization that needs that certificate that is on charge of the quality of the surgeons, and there is a culture that a surgeon should certificate sometimes that his proficiency in surgery. In Europe is not needed. There is only a project that the UMs United Europe Medical Specialization, something like this, that they try that you can really do, you can get the board and you can get the certification, but it's a personal basis and just for you for a curriculum purposes. I think that we need to move the idea to the need of this kind of recertification. You know that in this country is quite difficult because we don't have recertification. We don't have final examination after the residency program. But that's something that is quite clear is that after a 5-year period of training, you need to pass an examination in order to know you are able, you merit in this kind of distinction. I think that at this moment it's very over. It's a problem completely over. But I think I think that something important is to have the tools. If you have the tools to evaluate, it's much more easier to implement this possibility. But I think that it's a matter of culture. I don't know how surgeons or urologists, etc., will receive the obligation to be recertificated in Spain or in Italy. I don't know. But it's a matter of civilization. I think that should be. But
and it could be possible to have in Europe a general program for training surgeons, or it's difficult?
I think that is quite difficult. Europe is not United States. Europe is 27 countries, different systems. Very proud every one of his own system, and to go to a overall. We are trying. In fact, there is a overall the Bologna system in the university studies, but at this moment I think that this probably is not easy. It's not easy at all. It's a good idea, probably it's necessary, but maybe at this moment maybe it's too soon. This is my personal opinion.
No questions?
Okay, thank you very much for your talk. I think that was very clear, and also I think that we learn a lot about all the process of training. What's your view, your vision about the future of virtual reality simulators in this the process of the training programs for minimal invasive surgery compared with physical simulator, box trainers, and within this view, what do you think that are the real needs coming from this type of virtual reality technology to be fully integrated in this type of training programs?
That means for training program in video-based virtual reality, simulation, complete electronic simulation. Well, you see here also probably surgeons like to be in the something that is as similar as possible to the patient, and probably the best is the peak. Probably is the living animal. The second one is viscera, maybe preparated simulation. Maybe the third is some kind of hybrid, in which, but I suppose it's quite difficult, and maybe it's a good area for investigation for you, is to try to this simulation from the point of view of electronic, that it exists, electronic instrumentation, but over video-based living animals. That is because the problem probably is the haptic. The problem is to feel. You know that when you're operating, you feel much less the texture and the thickness and of the tissue. But from my point of view, the problem with the virtual systems that you lack completely this kind of feedback. Maybe now there is something to be evolution, and then is the realistic, the reality of the device.
Thank you very much. Could you estimate or speculate something concerning the involvement of robotics in minimal invasive surgery?
Now, currently?
For the next year, what could be the percentage, more or less, of the operations?
Well,
if you could speculate.
The robotics, we talked before about the robotics. When we talk about the Polish presentation on ergonomics, the solution for the problem in my shoulder, I have a pain from here
the end of the finger, the 24 hours per day from since 10 years, is the robot. The robot is a wonderful idea. And the robot, at this moment in Spain, I think that there are 8 or 10 robots. And the facts are that really robots is a wonderful technological idea, really is spectacular. It doesn't offer better outcomes for an expert surgeon than conventional laparoscopic surgery, except some very, very delicate cases and the prostate in case of the urologists, seeing that the prostate. And the problem is then the value of the procedure is too high because the outcomes are very similar to the conventional laparoscopy. My feeling is that the robots, the problem is, the first of all, is to reduce. I don't understand, probably is the Da Vinci monopolio. And I'm convinced that the future is with the robots. For us to operate seated with a wonderful view, with a complete immersion, with all the movements of the finger. What we can talk about ergonomics, but the problem is the same. The problem is the same because you need to be operating like this. And it's impossible do not operate it like this because there are not instrumentation. In spite, there are more than 20 years looking for different devices. Then, my question at this moment, the situation is, the robot is at the same level that conventional surgery, doesn't offer better outcomes, but the potential advantages in the case of a lower price is better comfort and easier training, because the step between open surgery to endoscopic surgery through the robot is much shorter, because it's much easier, because you are operating in the same way that you are operating in open surgery, with 3 dimensions and all the movements of the hand. This is the problem when you are operating in conventional laparoscopic surgery, 2-dimension, and also with the freedom degrees of the end of the tip of the instrumentation. And my feeling, my hope is that in years there will be open market with smaller robots, with cheaper robots, and the robot will be something in the ceiling of the operating room. And when you make some special part of the operation, you give the robot, make the procedure, and continue, and something easier. But I think that something that is absurdo is the current situation of the too much expensive.
Questions? No? Thank you very much. Thank you.
Good morning. My name is Antonio Arco, and I'm an associate professor from the Superior Health School from the Polytechnic Institute of Porto Alegre in Portugal. I want to thank the invitation to present the MITIC project, which acronym means technological modernization and innovation based on information and communication technologies in strategic sectors and traditional sectors. This project includes several activities and several tasks. We are directly involved in the activity 3, exchange of knowledge for innovation and entrepreneurship, more precisely in the task 3, information and communication technologies based learning, for the specialization in minimally invasive surgery in the surgical team. This project takes place under the Spain and Portugal cross-border cooperation, having started in December 2013 and is scheduled for conclusion at June 2015. In this particular case, the partners involved are the Jesus Uzon Minimally Invasive Surgery Center of Cáceres and the Superior Health School from the Polytechnic Institute of Porto Alegre, under the coordination of Professor Francisco Sanchez Margallo of the center already cited. The main objective of this project is establish of a cross-border cooperation, enabling the creation of pedagogical and didactic bases to develop a training system based on information and communication technologies that provides a useful and simple tool for all the components of the surgical team to be able to specialize in the most advanced minimally invasive surgery techniques. The specific objectives of this project are address the needs of specialization and training of health professionals, to promote and to increase the labor market opportunities for all the components of the surgical team, facilitate the access to high quality didactic materials to all healthcare professionals, allowing greater implementation of new minimally invasive surgical techniques in healthcare systems worldwide, and generate the necessary knowledge to reduce the delays of this Euro region in terms of new developments, which allow us to position this Euro region as a reference in the application of forefront surgical techniques. The project development is divided into work packages in sequence. The package 1, establishment of clinical and technological requirements. Package 2, development of a pedagogical model. Package 3, development of surgical didactic contents. And package 4, system validation. The final package, the package 5, management and diffusion, is overall transverse to the course of all the project. The package 1 and 2 are currently nearly concluded. The work package 1, establishment of clinical and technological requirements, under the responsibility of this center with the participation of the school from Porto Alegre, includes the following tasks: the definition of use cases and learning scenarios, the definition of user requirements, and the definition of the system technical specifications. The work package 2, development of a pedagogical model, under the responsibility of the school with the participation of this center, includes 4 tasks. Develop a pedagogical framework, competency-based criteria for the minimally invasive surgery learning model, the skills evaluation for the competency-based learning, and the final design of the minimally invasive surgery learning model. The work package 3, development of surgical didactic contents, under the responsibility of this center includes also 4 tasks: classification of existing videos and the recording of new surgical videos, the edition of the videos recorded, and the creation of new didactic contents. And finally, the creation of one learning environment as support of the contents. The work package for system validation, under the responsibility of this center with the participation of the school, includes 4 tasks: the validation plan definition, the pedagogical model validation, the initial pilot study, and of course the final tests. The work package 5, management and diffusion, under the responsibility also of this center with the participation of the school, is, as I said, mostly transverse to the course of the project and includes 2 tasks: the project management and the dissemination of the results. The main performance indicators established for this project are: 1 supported project for production of digital educational contents already in course, 2 public entities benefited with the execution of this project, 10 researchers benefited of this project development, 1 line of investigation supported at research centers, and 1 new cross-border line of investigation created. The main indicators to monitor the achievement of the objectives are: 3 research work publications, 1 cooperative network linking cross-border research centers in areas oriented for the resources evaluation, 1 new project generated by the activity performed by this project, and 6 news published in different media on the subject of the investigation, 3 in Spain and 3 in Portugal. And this way, I have concluded my brief presentation of the MITIC project. Thank you for your attention. If you have any questions, I am at your service to try to answer them.
Is there any question? Thank you.
Now we'll connect again through video conference with Enrique de la Cruz, researcher at Everest, Valencia, Spain. Hi, Enrique. Can you hear us?
Hi.
Hi. How are you?
Fine, at last.
It's a pleasure. Could you stay here? You can start your presentation. Thank you.
Okay. So first of all, I want to say hello to everybody, and I'd like to thank Blas and Luisa for inviting me to this workshop and all the team in Athens. Okay, so I'll show you the screen now. Right. So during the following 10 to 12 minutes, I'll be talking about Project Mistela, where we are collaborating with the Centro de Cirugía de Mínima Invasión Jesús Usón, as you know, and Universidad Politécnica de Madrid, among other partners. So, and I am the one talking here because I represent Everest, project coordinator. So just a few facts about Everest. We are a multinational consulting firm established in 1996, and not so long ago, in January 2014, we became part of Entity Data in January 2000. Okay. So this big group we belong to now, Entity Data, has established, enabled Everest to offer a wider range of solutions and services through increased capacity as well as technological, geographic, and financial. So a bit more about geography. So together with Entity Data, we are almost present in all the globe, but Everest ourselves, we are present mostly in Spain, but we also have offices in London, Rome, Brussels in Europe. But we also have quite a presence in Latin America. So a few facts, like right now we are over 70,000 professionals in over 41 countries, and there are some other facts that you might find interesting. And we, as Everest, will represent 1/4 of all the Entity Data operations outside Japan. And just a small figure, we work almost in all sectors like banking, public sector, telecom, manufacturing, insurance, utilities and energy, and yeah, as you might think about health as well. In the health sector, to be more specific, we have developed our own software development framework and have participated and coordinated in several research and innovation projects funded by the EU. So, and after this short presentation of Everest, I want to concentrate already on the project itself. Mistela started in 2012 and is a 2-year project with a budget of over 500,000 euros and a consortium formed by 5 members, as we will see in detail afterwards. It is funded by the European Commission. It's funded by the Lifelong Learning Program, which I believe most of you know already that has now is now the new Erasmus Plus program. Okay, regarding the objectives of the project. So we have a primary, our main objective is to develop a pedagogical model framework of the fundamentals for a European MIS training. This framework, what we intend to do with this framework is to fulfill the specific learning needs of surgical professionals in order to enhance their competence for MIS. But it should account for the necessary means to, 1, enable formal training, and 2, support non-formal learning. Besides, it should facilitate informal on-demand learning. But furthermore, you have to think about that if we are developing a pedagogical European framework, a common MIS learning program will facilitate professionals' mobility within the European Union. Our secondary goal has been the development of an ICT solution as proof of concept for the implementation of such pedagogical framework. This environment is providing and will provide a collaborative context for MIS training and an existing video-based authoring tool which users will be allowed to access multimedia didactic content and will have the possibility to contribute with new ideas and new edited content using it. And finally, of course, our third goal is to validate with end users the previous pedagogical model. And regarding the consortium, I must say one of the biggest strengths of the project has been this consortium. Three main profiles were sought in the establishment of the consortium. First, there had to be partners with wide experience in the clinical field. Second, there had to be partners with background in learning theories and pedagogical modeling. And finally, there had to be partners with technological and communications knowledge required for the development of the ICT supporting tools. As a result, we conformed the following consortium. Together with the Centro de Cirugía de Mínima Invasión Jesús Ursón and the Universidad Politécnica de Madrid, together with us, with the office in London, two more very relevant partners closed the consortium. Delft University of Technology from the Netherlands, and the largest independent research organization in Scandinavia, SINTEF. So, the way the project has been structured is first by acquiring the clinical needs in the early stages of the project. Okay, sorry. So we have acquired the clinical needs in the early stages of the project, and this, together with literature review that was made very intensively, so to say, has enabled us to design the pedagogical model and afterwards the supporting environment. Now, I will describe a bit more about these three main areas of the project: the pedagogical model, the environment, and the validation. So, concerning the pedagogical model, the model forms a set of guidelines that will allow teachers, course designers, and students to fully take advantage of any learning environment, and as well as the associated advantages derived from the different tools, including informal learning among users. The model describes the suggested tools and resources and their use for the aims. The learning model actually has been developed for MIS training in based on a 3D pedagogic framework. The framework is a flexible tool for aligning learning theories from different educational institutions, training providers, course designers, and teachers with a standardized formal training practice. You must think that if we are developing a pedagogical framework valid throughout Europe, we should be flexible enough to join all already available pedagogical frameworks. So, regarding the tool, Mistela proposes a collaborative learning environment based on web technologies structured in three main pillars: an authoring tool for the creation of augmented video resources, offering the means to boost the didactic capabilities of hospitals and training centers and their video repositories. Also, a media asset management, so-called MAM system, for intelligent storage, annotation transcoding, and edition of augmented, non-augmented videos. And finally, a technology-enhanced learning environment, providing the means for first creation, edition, and visualization of courses, interactive collaboration between users, and tools for assessment and monitoring of skills. The latter one is based on the environment. Here you have a more detailed view of this architecture, where you can see that the TEL environment is divided into a professional network, an assessment skills, and the courses themselves. So here you have some screenshots of the final implementation that is being validated now in the trials. Like here, the main entrance to the courses, the different courses available and the content inside those courses, all based in Moodle as mentioned. And here the different sections within a course. Here is a screenshot with the embedded viewer, but I must say this authoring tool will be described in detail by my consortium colleague, Enrique Gomez from UPM, in the following presentation. So, and finally, the validation of the project that is being carried out right now. The validation plan of the Mistela Technology Enhanced Learning solution comprises three main stages: the pedagogical model validation, the technical and usability test through an initial pilot study, and an investigation of users' perception and approval through a larger trial with end users. So what we suggested it should be better to be done in Mistela is to perform a validation of the pedagogical model in two stages, actually, by itself. The content validation and the multidimensional validation. The content validation is done in order to find out how accurate the relevant the content of the implemented courses are. And on the other hand, the multidimensional validation of the pedagogical model is done in order to refine the description of the model and validate the staff hypothesis. So this is a basic presentation of Project Mistela. If you have any further questions, please ask, or you can visit our webpage, www.mistelaproject.com, and or contact us directly via the project management office or any of us. Thank you very much.
Thank you. Is there any question? Okay, thank you. Next presentation, next speaker, Professor Enrique Gómez Aguilera. He is a close collaborator of this center. He is Professor of Biomedical Engineering at the Polytechnic University of Madrid. Thank you for coming, Enrique.
Okay, well, thank you very much, Dr. Sánchez Margallo, just for inviting me just here to share with all of you some of the work that we are doing and also to share experiences and discussing in this, of course, always beautiful center that I'm very pleased always to come. As you said previously, within this collaboration that I think that started almost 15 years ago, I think that we are getting old. And then I think that I'm very happy always to be here and to work with all of you. Well, the goal of my talk will be based in the idea of presenting some results about how we are thinking and using these video-based technologies, mainly the analysis of the endoscopic video, in order to apply for the field of training in minimally invasive surgery. It's also related with the presentation that was done by my colleague Enrique de la Cruz from Everest Company, because in some way some of the technology that I'm going to show is has been already done, already developed and tested in the Mistela project. Well, when we are just speaking about this training of minimal invasive surgery skills, I think that is well known. This is the context we are in a very specialized center and also with a specialized audience that we are thinking in also in just learning and training about non-technical skills, where in that case there is the possibility just to teach about the anatomy, about the complications, about the judgment, something quite important, about the steps of the procedure. And also when we are thinking about this type of skills that have to be trained are the technical skills. And specifically when we are speaking on technical skills, that depends on the surgical technique that we are in that case focused on. For example, in the case of laparoscopy, we have just to think in visual, in that case, spatial perception, haptic perception, and many other things that already has been presented along all this workshop. But, well, at the same time, it has been already just highlighted before that in the case of missed training, some challenges are still there. Of course, the first one is the acquisition and accreditation of the necessary competences, of course, without compromising patient safety. And in this case, the role of simulation, both virtual reality, physical simulation, many others possibilities are, in that case, taking a more and more important role, as I said. Also, it's important to do this type of objective, to look for ways and methods to do this objective assessment of skills, because having this objective assessment of skills, we can develop just objective and structured learning programs. Something that is also so important, because in that case we can look for time and money savings. Of course, we have just to go to be adapted to the European Working Directive, of course, to try to standardize pedagogical models, as also some of the work also was presented in Mistela project. When you look and we look at the technology, that's obvious that technology is getting more and more important roles in this type of field, and even providing new paradigms that are changing the way in which education in minimally invasive surgery is performed. And then we have technologies like virtual augmented reality simulators. Of course, we have e-learning platforms. Many examples have been presented today, serious games, and also the possibility of analyze what is happening when this training process is done. That can be done in that case in specific centers like this one, just in experimental operating rooms, or just in the real operating rooms. What is in that case the focus of my talk? The focus of my talk is to try to see how can we exploit as much as possible and use the information that is always already in the video. I mean, the video is always there. We are continuously recording these videos. These videos are stored afterwards, can be used just to extract the information, create new learning and training methods, and this is the idea of the analysis. It's a source that is always present, and it's something that is always there. Is in some way this source is transparent to the surgeon. I mean, it's not producing any difficulty or any just a complication just for collecting and processing. It's a non-obtrusive way. It's a cheap alternative, something that can be done with the information that we already have, and something that can be used directly to the operating room. And then if you don't have any other technologies, any other equipment just to be used within the real world. And then in the case of the endoscopy video analysis, we can just have two main streams. The first will be just the exploitation of this existing video applications, creating what we call augmented didactic contents from these raw laparoscopy videos, and a second just way just to use it, that to try to look for sensor-free alternatives that not modify the ergonomic and workflow, but at the same time allow to analysis what is happening regarding, in that case, mainly the psychomotor skills. And this is something that we started to work just several years ago in order to develop procedures, algorithms, methods that allow the possibility to analyze the video and from there extract useful information to be applied for these minimally invasive surgery training procedures. Some examples are the one that is shown here in this slide, where we have the video and we can just analyze using methods like they are called filter-based segmentation, based on color, texture, shading. Several procedures probably are out of the scope just to go in detail, where we can just do a segmentation of the different organs that are in that case present during the surgical operation using the 2D information. And from there, not only to analyze and to have where are the different, yes, and in the case areas or organs, but to do a tracking
of this structure. I mean, where the process is, in that case, just moving, just to know and to continually have just adapted these areas, these organs, to the movement of the surgical intervention. And the same manner to detect and tracking singular points. That case, with a specific algorithms, detect, in that case, we can say local features that again will be present and move along this intervention. A second just area would be not only just to know how the organs in that case or any other area of this anatomy of the patient are analyzed, but specifically the instruments. In that case, the surgical instruments, we can do just a segmentation, detect where is the instrument, and afterwards to do the tracking, how this instrument is moving. Determine where is the tip, just of the instrument, and from there, just detect to do from the 2D tracking, just to determine and to define the 3D pose of this laparoscopic instrument, and to know the movement of the tip along, again, the surgical intervention. But basins, and again, several types of algorithms that are some of them presented here, based in color, based in a specific, in that case, transforms, or just using some of the possibilities to do just some specific marker within the tip. That, well, this is not an approach that always is used, because in that case you have to modify the instrument. A third just procedure will be, in that case, to estimate from these procedures where are the different areas and also the instrument and the distance between just the depth of the organ, the depth of the specific components of the surgical scene, and then in that case we can have these relative depths, these absolute depths, and to do something like a reconstruction of the shape of the surgical exam. That is trying to move to a 3D information that collecting from the video, you know that we have only the 2D information. Some examples in that case are shown in this slide. And the fourth procedure will be just from this information, just to define where are the trocar points, just having this information, where are located the trocar points, and even where is the endoscope position. And from there, we can use this information also to have more or the information regarding where has been established, and from there estimate all the different components of the surgical scene. Again, well, estimating the pivoting point, or using a more complicated just procedure like they are called monoslam or optical flow, that again, as I said, estimate using with the illumination and with several techniques how we can define where is the endoscope at any position. Well, and then all these procedures have been, as I said, continuously developed, in that case, driven by the application. And the first one is the application of the cognitive skills learning, and then is just to apply for creation of these video-based didactic contents, something that I said, as I said before, my colleague, Enrique de la Cruz, has been also applied in Mistela. I will say a few words afterwards. And the second one regarding the psychomotor skills training, as I said, they try to do the sensor-free tracking of the laparoscopic instruments within a system that is called Endoscope Video Analysis Tracking System, EVA, and that again applied in the Chiron training system that also was presented early in this morning in this session, where we are trying just to tracking, just how in that case the student is performing with a serious game, and also they have the possibility to replicate the motions that the students are in that case doing when playing with the game. Moving to the first one, as I said, the idea is to create these augmented didactic contents, because it's obvious that we are continuously creating these multimedia materials that are stored, that are in that case sometimes used, sometimes are not used. And then the answer is, the question is, can we create with these contents a more just video-based didactic units? And these augmented videos, in that case, what we are doing is structuring these dynamic layers, where on top of the video, we can just incorporate this type of layer that we have interactive assessment, object tracking, the possibility of including text, audio, something like a layers that are in that case superimposed of the original video. And from there, in order to do this, we created what we call just a tool that is called Amelie. Amelie authoring tool is something that in that case allow to the learner and allow to the teacher just to use any of the different layers depending on the needs and depending on the didactic unit that in that case is created. As I said, so, adding the information about the text, information of an audio that is recorded, in that case synchronously with the video, having the possibility, as I said, of tracking any component of the surgical operation, to select part of the video. I think that to say, okay, this is the critical area, the critical procedure, the critical step that we're going just to stress during the surgical procedure, or even just to incorporate interactive questions that can be, in that case, adapted to the learning curve of the student when using this video. This, as I said, is something that this tool has been further developed and integrated in the Mistela, and already just evaluated in some of the data were presented in the previous talk, as allows the system just to generate the different didactic videos. At the other side, we go to the psychomotor skills learning. In that case, the event tracking system, as shown in the slide, allows continually to know where is the instrument, from there to estimate the position, and to do this 3D position about the laparoscopic instrument, in that case, in a box trainer setting. The box trainer is an easier way just to do this type of tracking, and the algorithm has been optimized for doing this. And also, in that case, we are now in the process of transferring to the operating room. And this is the type of technology that is used in the KTS, or is going to be used in the KTS project that is starting running. Well, they are based on several strategies, based on projected geometry algorithms that, again, I'm not going just to further explain. And from there, how is the real use? The real use of this type of algorithms has been just to, as I said, to capture of the different movements in the box trainer, and then we afterwards know how the instrument has been, in that case, tracked, and to generate this data stream, we are generating this database of all the different just movement and how it has been done, and synchronized with the procedure adapted to the serious game. From there, capturing this interaction, we can replicate the game because we know how, as I said, has been performed. And finally, we save all this data stream because we can do from there an objective assessment of how the procedure has been performed and how the procedure are, in that case, learned, and has been, in that case, the evolution of the student using this type of technology. Well, just finally of this presentation, just to draw some conclusion. I think that well, endoscopy video analysis is, in that case, a power source. It's a powerful source of information that is always present and can be used in many possibilities. One that I presented, it was in the field of minimal invasive surgery learning. We are also using in the field of image-guided surgery and incorporating this type of image processing and video processing tools for this type of application. We call image and video-guided surgery, as the video is, again, a source of information that provides to the surgeon during the operation a lot of information. Some of the procedures that I said that presenting, and we are not going just to give data, are already validated in mixed learning, training, and assessment applications, and mainly in two main projects, as I said. One in the case of Mistela project, where this Amelia-Thorne tool has been playing this supporting role for creating these augmented and didactic units. And finally, the EVA tracking system that will be some of the techniques and methods used in KTS project as a basis for analyzing all the different movement, capturing data, and afterwards to know how is the real performance of the student when using the KTS serious game. Well, thank you very much. I don't know if you have any question.
Question? Yes, after 15 years of collaboration between us, I have a question. I want to say, what's your idea about the possibilities that technology could offer to minimal invasive surgery in the future? For example, computer-assisted surgery, robotic surgery, I don't know. What's your vision, technological vision for the future?
Well, I think that one of the key ideas that in some way I try also to present and to discuss with all of you is to try to simplify as much as possible some of the technology, because it's obvious that the operating room is more and more, in that case, technology, we can say, crowded, that we are putting more and more technology within the operating room, and we have to try to just to find solutions that complicate as less as possible the real problem of the surgeon, that is to have information in real time and also a better knowledge about how to face the specific just procedure. Some of the possibilities, as I said, is regarding this type of tools that can be used not only for learning, as I said, but also to be used during the surgical intervention. Because it's true that medical imaging have many possibilities, but medical imaging is again very expensive, and some of course, the modality of medical imaging cannot be used during the surgical intervention. The other one was, in that case, in the preoperative phase. In the preoperative phase, it's obvious that, of course, we have to think how far we can go to the virtual reality simulators. Well, also this morning, this was something that was discussed just in the master session. And again, what we learned is that the technology, sometimes we thought that technology can do everything. It is not the case. I mean, I think that there is no way. You can do some of the training with better, just we can say this type of hybrid simulator, probably virtual reality simulator, is just in some way that is very difficult with the technology that we have now just to advance more. And then I think that probably, as I said, the idea of using these hybrid simulators just to reduce the learning curves and to go further to the we can say laparoscopic basically just skill, something that already is solved, that I think that is something that we have to do. Of course, we can say the optimal way will be just to play and to real train with what we call a virtual pacing before starting the surgical intervention. But I think that we are very, very far just to do something like this with even we didn't manage just to do with a cholecystectomy, how we are going to do with others. And then I think that the other just stages, as I said, is to try to do with the robots that also we were discussing. But I think that the technology again is something that are not in that case providing enough solutions. What is in that case used. Probably I think that the integration of the different technologies and the use not in an isolated manner will be part of the solution. Just to use, just in that case, robotics in the way that has to be used and not always, because probably not all the different surgical interventions, to provide as much as possible information during the surgical intervention, and to have decision support systems. Why not to provide, in that case, we have a lot of possibilities of collecting data, but these data are not providing in background intelligence to the procedure, because in that case the surgeon has to process a lot of information that already collected for a specific knowledge for one specific patient, and we are not in that case supporting or providing something that are decision support systems that in some way are doing clues about where are the different the procedures that in that case can be more complicated. What are the difficulties about where are the areas that can be in that case more critical for one specific procedure. And I think that is also another area regarding what was called in the past artificial intelligence of data mining techniques, wherever, because it's true that the knowledge that in that case applied, a lot of knowledge for one surgeon, for one specific intervention, in many cases is not used for other surgeons and even for learners and students that are facing the similar problems in other patients. And this is something that also we have to explore about how to use it.
Questions? One question?
Thank you very much. My question is if you have studied the trajectory and position orientation of the laparoscopic material into the box, or it is out of your interest, because I'm very interested to study that in order to see if there is consistency concerning the approach of the surgeons to the point where they must do things, and also to combine posture variation with the movement into the box.
Okay, as shown here, yes, exactly. What we are doing there is to know exactly where are the different positions of the instrument, and then we know the trajectories, and we can do definitely in real time in this type of box trainer. And then, as I said, in the case of just the operating room, it's very much more complicated. You know, the algorithms are not working but in principle we can do. What we have not done yet is to combine this information with just, in that case, the information regarding the ergonomic position about how the hands, as we said, how the arms, and all this in that way, if you are optimizing. Well, I didn't just what it was not part of the goal of this presentation, but most of these tools are already used, and we did also some research work, also in collaboration with this minimal invasive surgical center, in order to use this tool for the objective assessment of the performance of the different skills. And well, also some papers are already published, and then this is another area to say, okay, you have this technology to assess how the students are learning and how the student, why one student have this learning curve and the other one has the other one, and how they are performing in some specific procedures. This is something that you can do. In that case, we can say in an easy way in box trainers with this type of technology.
I don't know if I could continue with my question. Okay. I suppose that linear acceleration during the approach to the point is very important for the control process, and that implies the stabilization of the posture. That means muscular intervention and fatigue. So my proposal could be to collaborate in this kind of approach, studying the external posture with the movement into the box.
Yeah, if I understand well, what you said is just to have just to combine the metrics in terms of I mean, just the speed, just the position, the time. But this is something that is also very difficult. It's sometimes tricky, because it's true that even we don't have a real consensus about when we try to evaluate just the competence of just in that case a junior, just in that case surgeon with a real just expert. Well, the procedures are not sometimes very well. There are a lot of just experience that probably we can discuss, because several PhDs have been also done in this center and also in collaboration with us, and it's not so easy just to speak about the different metrics and how you can use afterwards to know if the influence of probably just the final fatigue or the different problems regarding the surgeons. But probably we can further discuss.
Question? Thank you.
Okay.
Last speaker will be Dr. Professor Florencio Monge. He is the director of a Foundation for the Study and Development of Implantology, Oral Surgery and Maxillofacial Surgery. From Badajoz, Spain. Thank you for coming, Florencio.
Good afternoon, everyone. Firstly, I would like to be very grateful with Jesus Uson Minimal Invasive Surgery Center, especially with Jesus Uson and Francisco Sanchez Margallo, is the fathers of this idea, but especially to the engineers, José Luis Moyano and Blas Contador, because they helped me in this adventure. We can see simulators in normal life. Today is September 12th. Yesterday is September 11th. Satellites located Bin Laden's house in Pakistan, and Navy SEALs, this is the Special Operations Force. They train the detention and death of Osama Bin Laden by using a real simulator, one-to-one proportion, building an area and house similar to the Bin Laden's house. And they train day by day before the operation. Our Fernando Alonso, our super driver, spent 2 days by week before the race in order to save money, to save petrol, to save wheels, keeping security. Historically, the most used simulator in medicine and surgery were cadavers. It's a classical image. Professor and students meet around the cadaver in order to show different aspects of the anatomy and the function of organs. But many medical professionals are very skeptical about simulation, saying that medicine and surgery are too complex to simulate accurately. This is the definition of medical simulation. As you can see, it's in relation technology with education and training. And this is the rescue ANA. This is a model of cardiopulmonary resuscitation, CPR, used to both in emergency workers and members of general public. The rescue ANA was developed by the Norwegian toy maker, Asmund Lerdo, and the physician Peter Safar. What about the temporomandibular joint area? Temporomandibular joint is a joint located in the preauricular area. It's very special and delicate joint. Anatomically, the disc divided the articulation and the joint in two compartments, the superior compartment between the temporal fossa and disc, the inferior compartment between the disc and condyle. Please pay attention to the position of the disc because this is the key factor in the pathology of the temporomandibular joint. We have symptoms such as clicking, sounds, pain in temporomandibular area, and closed lock. Closed lock is reduction and decrease of the oral opening. Up to 30% of the population may suffer any kind of symptoms of internal derangement along the life. We can use conservative treatment, physiotherapy, some exercises. The spleen, this is oral appliance, different medical treatments such as relaxants, anti-inflammatory, analgesics. And finally, we perform the surgery in 5 to 7% of the patients without any kind of answer to conservative treatment. This is the open surgery. The open surgery is the more classical and the oldest surgery, very aggressive. The scars, difficult rehabilitation, problem with the facial nerve. And 20 years ago, we started training in endoscopic surgery by using arthroscopy before different open joint surgeries. We go into the joint with a cannula with a point trocar. After point trocar, we change the point trocar with a blunt trocar. And finally, we put a lens and arthroscopy into the joint. We can see different findings, such as elongation in accordion, displacement of the disc, synovitis, adhesions, chondromalacia, perforation of the disc. But the next step is therapeutic surgery. We put all the cannula in the anterior approach to allow different therapeutic techniques, remembering all techniques, the open joint surgery techniques. We get lysis of adhesions, myotomy of the pterygoid muscle, electrocoagulation with radiofrequency, the most sophisticated techniques such as suturing techniques. How to teach or learn this endoscopic surgery, these endoscopic techniques. We wrote some years ago, it's a classical book, paper book, but 7 days ago we put in iTunes store a new book for iPad with videos, photos, is very interaction, but this teaching is really theoretical, very visual, but not practical. We have different group of studies in different countries. We teach in South America and Europe, but theoretical meetings without any kind of practical exhibition. In some cases, we use other models, such as cadaver workshop. 3 problems, in my opinion. It's not possible to get cadavers, good cadavers in some countries. In South America, in some countries, it's not possible to get cadavers. In Asia, it's not possible. In Europe, in some countries, such as Italy, it's quite difficult. This workshop is expensive. You have to pay 2,000 euros by 1 day of workshop. And finally, you can't find any specific pathology in the cadaver. BAST is the best model at the moment. For this reason, we approached the adventure of simulator 3 years ago. We tried by ourselves at this center to discover materials similar to skin, ligament, muscle cartilage. We recognized after 1 year the difficulty of these projects. You know that this is a special sentence in Spain. Withdrawal in proper time is a victory. For this reason, we make a contact with a Brazilian company, very experienced, is a leader company in other kind of medical models. The headquarters is Olinda. Olinda is in the north of Brazil. And we traveled several times to Olinda to work directly with the technicians and workers of this company. It's a company not so big. Marcos is the boss. He's a gynecologist that is very obsessive in the field of the new medical simulators. It's a handmade company without any kind of industrial management of material. The material to make different tissues is top secret for this company, but the workers are very skilled, are detailed by using this material. They are very artisans. It's very funny how this artisan used the soldering iron. It's very real, the products. Even they have collaboration with some companies specializing in special effects for movies. You can find birth models, knee, shoulder, laparoscopy, cystoscopy, neurosurgical model, but until recently, this company doesn't have any facial simulator. Anthropometrically, we start for the joint with temporal fossa, condyle, lateral ligament, capsule. Our first approach of the joint, this cannula is 2.5 millimeters of diameter. We put layer by layer different structures such as lateral ligament, masseter muscle, temporal muscle, temporal vessels, parotid gland, and the enemy number one of this surgery, this is the facial nerve. And it's our first arthroscopy 14 months ago. We can see adhesions, some structures, some masses in the internal part of the joint, some vessels. We are satisfied with this view, but we are not happy enough. After this first experience, we wanted to improve the results, performing different repairs and remodeling. The final product is Miguelito. The name Miguelito is why this name. This is the key factor, because it's quite similar to Miguelón. Miguelón, as you know, is a protagonist of the Atapuerca site. As you know, Atapuerca site is the most important site in the paleontology in the world. And Miguelón is Homo heidelbergensis. And you can see the similarity is obvious. Otherwise, in the real operation, this line between external canthus and tragus is a reference line. The puncture is very similar to surgical experience, is with cannula 2.3 millimeters of diameter. We're inside of the joint. Is very well done the aspect of the internal joint. You can see the temporal fossa and the condyle. We move to the anterior part of the joint. This area is really similar to the human being. But we need to train second approach to the therapeutic approach. Is inserted a cannula with trocar in the anterior part of the joint in order to put into the joint different structures, different instruments. And this area is quite important. This is pterygoid shadow. This pterygoid muscle is area we need to approach to do some therapeutic maneuvers. We need a validation. We meet at this center 2 months ago different specialists. Some of them senior specialists, very experienced at this field. you can see even how we train the most sophisticated techniques, such as suturing techniques. We do different surveys in order to know the failures and advantages of this model. The feedback was acceptable, even rewarding for these specialists. And which is the future? The future of Miguelito 1.0 is Miguelito 2.0, and the future is based in more maxillofacial operations to get better textures and sensation of layer of tissues, to add a unit serve as tutorial, and a system of evaluation of the practice with a score. Negative points if the surgeon touch some structures, such as vessel, facial nerve, and positive points if the resident make the practice with any kind of adverse effects. Thank you very much for your kind attention.
Questions?
Very nice, very exciting, especially to work in so small cavity. But it seems that this simulation is handcraft, that's artisanal. There is some role maybe for 3D reconstruction and printing to develop these models instead than handcraft artisanal. Which is the role of the new 3D printers after 3D reconstruction?
Yes, probably is the future. As you know, the 3D printers is the future in order to do this kind of model. But probably the artisan role is define some key factors in terms of pathology, adhesions, synovitis, some vessels, some delicate work of artisans.
Questions? Thank you. Okay.
As a final part of our workshop, we'll try to fill in a survey to achieve new ideas of we can improve the next workshop for our institution. Finally, our scientific director were the closing of the ceremony. Thank you.
Thank you. We are about to start the closing ceremony. Thank you for coming, and I would like to thank the presence of all speakers. We are very grateful to our strategic partners. I want to remark the important role that education and training have played and will continue to play in the minimally invasive surgery. I have some notes. I would like to emphasize that during this workshop, we have had around 50 attendants and speakers from different European countries, such as Germany, Poland, Portugal, and Spain. The speakers have talked about several topics related to advanced technologies for training in minimally invasive surgery, such as assessment of surgical competencies, e-learning platforms for training of surgical skills, ergonomics applied to the surgical field, surgical simulators, and so on. In this sense, the Dr. Targarona has provided us a very interesting talk about the clinical vision of the needs of specific training in minimally invasive surgery. And in order to deal with these needs, several projects have been presented. For instance, the LabForm project has provided 2 e-learning courses for ergonomic to laparoscopic surgeons and to laparoscopic instrument designer. On the other hand, KTA's Mistela and Mythic project have presented several e-learning platforms for training in minimally invasive surgical skills. In the case of Escolab and ITON project, different systems and methods for assessment of surgical competencies and surgical training concepts have been presented. And additionally, other presentations have shown a surgical simulator for maxillofacial surgery, methods for ergonomic assessment and development of training materials, as well as an e-learning platform for medical devices. And finally, I would like to thank you for attending this workshop, and I hope to see you again in coming events here at the Minimally Invasive Surgery Center in Cáceres. Thank you very much. See you soon.